and then you press mute.
Gotcha. Okay. Test 1, 2, 3. Yeah. Test 1, 2, 3. Test. Test. Yeah. Okay. So it's working. Yeah. Okay. So I'll disconnect so it can also.
Yeah. Yeah. Next person to try it.
I think I'm the second one, but you can go first.
But you're ready.
No, it's okay. You can go first.
It's okay. We have Katerina. We have your other. Yeah. And then.
So I'm Stephanie. Where am I? I'm here. I'm the second.
Okay.
Yeah.
John Key should be the third or fourth.
Yeah. So you're missing 2. Yeah.
Should I just?
Let's say, yeah. So
Are you presenting? Okay. More. Then we check it later if possible. Okay.
let's see. I'm trying to be as this one. maybe?
No, you can directly connect to HDMI.
Oh.
I think. Okay.
Right. Okay, so then, if I should,
Okay.
okay, so then when I share my screen
Yeah.
here. What I want to share is whatever's projected there so I can see my talk notes here.
So right now it's mirrored.
Okay, yeah,
So I think I need
should
to
I, okay,
unmirror it. Right? Let me see if I can. So I will distance.
Hello. I'm sharing.
it usually. So you can't choose a screen and Zoom, which one you're sharing?
Yeah, but it seems that it's mirrored, you see? So we need to split it.
Can I just see what happens if I just play the, because sometimes when there's another monitor hooked up, the keynote just does the right thing. Let's
Okay.
see what happens.
No, I don't have
No, I don't have the notes. You're absolutely right. Thank you.
Want it mirrored.
Hmm.
Stop mirroring, maybe. Okay, so maybe this.
Okay.
And
Could I
then
try the-
if you do this,
And then it's wonderful.
Goes
And there's the
by.
pockets.
and when sharing, you just click
Desktop
two,
too. Okay.
share,
And then
you come
hit
here,
play and it just
hit
works
play.
miraculously.
and
And
it's
that's-
showing the wrong
Yeah.
stuff.
It is?
Yeah, I selected the wrong
Okay.
one. Selected the wrong
Oh,
one.
so I select,
Desktop 2. I
Desktop.
was pretty sure I had selected that.
I think so too. I agree.
Now it's fine. See?
Okay,
That's what's sharing.
All right,
today.
so I choose desktop 2 and then I play. This
Exactly.
is wonderful, thank you.
Okay.
Can I close this one? I'm sharing that one. Yeah, I can. Okay, wonderful. Thank you so much.
Do you join Zoom?
Yeah.
Let's go with that. What do you need?
HDMI.
HDMI. You can connect to the directly.
So is it 20 minutes or 5 minutes question?
15 to 5.
15 and 5. And then I play the piano when it's time for them to stop. Did we continue that experience?
Or yell or throw something. It's your choice. You're the chair.
You're the
Um,
host and ask that.
Something disruptive.
What do you
All
need?
your power.
So if I go present
So many options.
and then
It's fine.
Okay,
You just
15
need
and
to
5,
share
got
the
it.
just.
And I'm also the boss of the question. Right? Okay. I do the fun part or while you do the real work?
Okay.
And wait. Yeah, perfectly fine.
Can I take it?
Perfect. Okay.
Yeah.
Yeah.
There are two people still missing. But, yeah.
USDC.
Okay, so you need this, right? And then go ahead. We'll need to split it. Notes,
No, no.
no notes.
Yeah,
Yes, it's easier.
so I can just.
Yes, but we need to share on Zoom.
Yes.
So it's only a matter of. Can I share the full screen? Of course, it's a slate. Desktop. And see which button, but should be fine.
I'll definitely make sure.
Yeah, yeah, I'll help you take
Yeah.
take there.
And
You can go there. Hide voting meeting controls. Yeah.
now clean up my background.
Yeah. Feel free or don't.
Oh, yeah.
Up to you.
Perfect. Let me just try one where the happen.
Is anyone presenting in this session? Just checking.
All right.
So
Thank you.
yeah, no worries. I'll be around until the one.
One, right?
Yeah, well, John,
Keep
yeah, nice to meet you.
Which one are you?
I'm third one. Sounds good. Yeah, relation.
Hello, hello. Good morning. They gave me a mic. All right. It's a pleasure to chair this session on co-creation. Reminds me of my very first ICCC 9 years ago, when somebody in passing said, and of course a machine can be a co-creative partner, and gave me for an idea for a company that I've been running for about 7 inspired. Super excited for an amazing lineup today. For our first one today, we have Catherine Maruzzi presenting the title you see on the screen. And the plan is that when the speakers have 1 minute left, you will hear a really quiet piano improv that may get louder. Just kidding. All right. All yours.
Thanks a lot. Thank you, everyone, for being here for this early start. So yes, hi, everyone. I'm Caterina. So today we'll be presenting a paper that I co-wrote with Solange Margarido from the University of Coimbra on how to customize the balance between user and system agency in human AI co-creative processes. So the aim of this paper is to think about a framework that shows all the dimensions that users should be able to modulate in their interaction with AI to allow them to customize the experience to their creative needs, style, and taste. So the idea that we start from is that the key aim of human AI co-creation is for the AI system to empower users. And for this reason, we aim at providing a comprehensive list of the key dimensions in human AI co-creativity that can be modulated by users to adjust the degree of control that they have over the process, thereby empowering them. And our second aim is to suggest an actionable way to actually put it into practice and to translate these dimensions of the framework that we present into a customization tool, which fosters the advancement of co-creativity systems that can be more attuned to user-centric principles. So here is an overview of the talk. I will be starting by focusing on one of the core concepts that we engage with in the paper, which is agency. I then describe the framework that we propose in the paper and how it maps onto core values in human AI interaction. And I will conclude with our proposal of implementing this framework into a customization app. So what the framework aims to do is to identify the dimensions according to which users can modulate their agency in the interaction that they have with the AI. But as I'm sure that you know, one of the key challenges when we talk about agency is that there is no universal definition of what agency is. So attributing agentive capabilities to a system may mean a lot of different things. It might mean that we recognize the system as autonomous and in control of their own actions. It might mean that we deem them responsible and accountable for these actions. And it might mean that we acknowledge them as the authors of their own actions. And in cases of special ones, like writing a novel or composing a piece of music, we attribute them intellectual concept. And the research that has been conducted around the modulation of users' agency identifies creative interfaces as broadly grouped around two ends of a spectrum. At the one end, we find more traditional creativity support tools like computer-aided design, for example, where the agency is in the hands of the human user. And at the other end, we find computational creativity, where, broadly speaking, the artificial agent is supposed to have more control on the process. But generative AI changed a little bit what's happening now with the control that the user has on the process. With the increasingly widespread use of these tools, the agency is shifting towards the artificial agent side of the spectrum. And it is therefore even more urgent to think about how users can be in control of these tools and what are the dimensions that they should be able to be in control of. And in order to do that, it's useful to investigate what is in the middle of this spectrum. I'm sure many of you know about the mixed initiative co-creative paradigm, which is a paradigm that has been formulated in 2014 processes in mixed initiative co-creativity, both the human and the artificial agent take turns proactively engaging in the process and responding to the actions of the partner. So in this paradigm, creative agency is somehow shared between the two agents and cannot be ascribed to one side alone. And this is the paradigm within which our work is situated. So next, I will be quite quickly go over what this framework is about, what the dimensions are about, to then move on to the values that it maps onto. So the actual framework has been published in a paper recently in an extended abstract. So you can read that to have all the details. I won't be going through all the details here, but the framework includes 9 dimensions, and each dimension contains a set of parameters which users can act upon to modulate their agency when they're interacting with an AI system. So the framework can be grouped under 3 main categories. The first category refers to the preliminary and the final stages of the human AI interaction. It is interaction guidance and response. The second category of dimensions is interaction configuration, and it refers to more formal aspects of the interaction between the user and the AI. It includes the dimensions of interaction interface, interaction modality, and feedback and adaptation. We will come back to those later. And the last category of dimensions is interaction dynamics. And this dimension is particularly important as it immediately impacts the level of agency and control that the user has on the system. So it includes the dimensions that are and AI interaction approach and task completion authority. So, okay, this is the framework. How can this framework help us understanding how we can reach the key values in human AI interaction? And the 3 values that I will be focusing on are alignment, co-adaptation, and explainability. So this is the summary of the dimensions, and starting with alignment in the context of human AI interaction in co-creative processes, we can understand alignment as the harmonization of preferences, strategies, and decision-making between human users and AI, which can be achieved only if the participants in the interaction share a common mental model. So this is why it's important to model the AI system behavior based on the user's literacy and experience, and that's done through the user expertise dimension. And then also the feedback and explanations that users and AI can offer to each other during the interaction, in particular in the context of the dimension of feedback and adaptation, can make sure that each co-creating participant in the process forms a rich and accurate mental model of their partner. And this ensures effective interactions. If successful, alignment between participants in a process results in the co-adaptation of the interlocutor's knowledge representation models in the interaction. So the feedback and adaptation dimensions in this model is designed to facilitate the co-adaptation between users and the AI. And by acting on the parameters of this dimension, user can select the type of feedback through which they communicate their agreement or disagreement to the AI. And in this way, the AI can adjust, ideally, again, can adjust the next moves to conform to the user's expectations and preferences. And on the other hand, the explanations provided by the AI assist users in comprehending the steps leading to a specific move or output. And users can then decide whether to maintain the same actions that they did in the past to encourage the AI to replicate the same outcome, or they can change if they're not happy with that. And the feedback and adaptation dimension is also significant, of course, for the third and last value, which is explainability. So as a field of research, we know that explainable AI aims at producing scrutable AI models that still maintain at the same time a high level of accuracy and performance. And research has shown how explanations are useful for building trust between users and the AI. So in the context side, so how the system is actually working and having control over the AI level and modality of explanation can empower the user to be more aware of the distribution of agency between themselves and the model. So the interaction modality is another crucial aspect of explainability, because the choice of the channel through which the user and the AI are communicating, so whether through text, just through can be voice controls and so on, can also determine the success in fostering a shared understanding between the agents in these collaboration processes. So that's all well and good, but it's still very theoretical, right? So the model in its current form is a conceptual guide to think about how the co-creative processes can be adapted to give users more control over the process. So in order to translate this conceptual framework into a functional system, we propose to develop it into a customization tool, which is still a prototype, a proof of principle rather. And the form that this prototype takes for now is an app, which can be either desktop or mobile based. But the one that I will show you is a mobile app, which is called Co-Create AI. So by using this app, the user will be prompted to select the limited, moderate, or extensive, and the choice made at the start will influence the layout of the app interface for the following steps. So here is shown what the user will be shown if they select moderate as an option. And in this case, the app would provide the user with the option to choose their preferred profile or AI persona that they want to collaborate with. So we thought about these different AI personas, and we identified 6 of them, which are here. So AI as assistant, inspirational source, idea challenger, colleague, quality control, and director. And you can see that, of course, the literature in computational creativity and also in mental models has inspired us in creating this persona. So in the paper, we outline the choices of parameters, which will be automatically selected by the app when the user chooses one of the 6 AI personas. So for example, if you choose to collaborate with an AI, which is an inspirational source, then the communication channel can be behavioral, so it adjusts according to your behavior. The kind of feedback that you receive is indirect. The processing, and it's not overwriting your choices, but instead is trying to provoke you to think of different actions than the one that you have just taken, and so on. But in the paper, there is all this table and the description of what AI, how AI, each AI persona is behaving. So this app could be applied potentially for now to co-creative tools of different kinds, so text-based interaction, game design, sketching, and so on. Game design could be particularly interesting for the multimodality, but also particularly difficult. So we will probably be focusing on just text-based interactions for the moment. And indeed, moving forward, we aim to develop a proof of concept of this app, and to ensure its effectiveness and user centricity, we will adopt an approach that builds the system incrementally, so having some user feedback and user tests. And the aim is for this app to not only enhance user engagement, but also address the inherent variability in human preferences for collaboration, acknowledging the importance of tailoring the co-creation environment to the diverse needs of each individual user. And with this, I thank you for your attention and welcome your questions.
Thank you so much. Is this on? Thank you so much for the very interesting talk. All right, we got a question right there.
Thank you for your talk. So I'm wondering how you define the features of the AI profiles with respect to agency, and like thinking about whether the functionality or sort of the traits of the AI co-creator, how those do they differ with respect to how they might lead to the system's agency, or how the human user would develop their own agency?
Yeah, no, thanks. So your question is aimed at understanding if each different AI persona has a different level of agency and control over the process. Yes, so definitely. So for example, there was the inspirational source that I was using as an example, as less agency over the process because it's not. So there are some dimensions that specifically refer to the level of agency, like the possibility of the AI to overwrite the user's action. So in that case, it's not overwriting, it's just suggesting. But there are other persona like the IS director, for example, that can take the option to override the user's choices if the AI determines is not aim towards the goal that the both partners have agreed at the start. So yes, so the idea is that when you start a co-creation with an AI tool, you might have different preferences, right? You might say, because I think we tend to think that we would all prefer to have more agency over the process, but it might not be always the case. It might be that sometimes you are just tired and said, okay, well, yeah, just I'll leave it to it. I trust you, which yeah might be a bit dangerous. But so the idea is that each AI persona might have a different level of agency and can have also more agency than the user over the process. But still, it's the user who decides at the beginning to attribute this agency to the system. Yeah.
Great. Is there another question?
Thank you for the presentation. I'm wondering, when you thought that there's different levels of agency, I'm wondering, have you came to any conclusions in which of these levels of agency result in better creativity of the co-creative system overall? So like, is there a balance, or what is the balance that results better results, if we talk the human and the computer as a whole and not as like just a human?
Yeah, that's a very interesting question, and is actually probably the core research question of this work. So the core research question of this idea is to understand what is the good trade-off and balance between agency and automation to achieve more creativity in the system overall, understood as the AI with the human, not just the AI or the human. So I guess I hope the user studies will help us understand that as well. So I don't have an answer based on facts now, but what I expect is that it differs a lot according to the kind of process that is undertaken and the kind of user as well, because then it's linked to the answer before. Maybe depending on the different types of users, one user might be more motivated if they have more control, and thus resulting in more creativity overall. Again, how do we measure creativity is another question, but so it's a great point, and hopefully this user study will help us shed more light on this. I don't think there is a unique answer, but that's maybe the point of this work, that each individual interaction has its own rules, and we want to account for that.
You adapt the level of adaptiveness to get best results.
Yeah, so the ideal, so in technical terms, it might be difficult to achieve, but the ideal is that the AI adapts in real time to how the user behaves, and vice versa in mixed initiative. Adaptation between the user and the AI is a necessary aspect of this interaction.
Katerina, I have a very quick question for you.
Yeah.
You mentioned that explainability can help with trust.
Mm-hmm.
Does the explainability have to be real for the trust to happen?
Doesn't. Well, Well, I am a philosopher, so I shouldn't say that, but and well, I don't want to repeat something that you all know about. So also humans cannot be fully explainable and so on. So I think there are two different dimensions in the framework that by crossing them, you might be able to receive a clearer answer in respect to how the system works. So in the model operation inside, you would be able to see how the model is built and how it works. Again, only if you have some kind of literacy, you will be able to understand it. And the feedback instead is what the AI decides to tell you. So it might be that it's not explainable fully, but by crossing these two dimensions, you might see if there are some some things that do not correspond and that do not agree with each other. And so, yeah.
Great. Thank you so much for
Thanks
the
a lot.
wonderful talk. Our next speaker is Ala Meloli. Please.
Good one.
Yes.
Yeah. Hi, my name is Ala. I'm today here to present you stories. I work with Raul from the Chair of Media Technology at TUM, Technical University Munich. So for the structure of this presentation, I first gonna go over a small introduction, then the data that we used for this work. Then I will go over the implementation of the two main components of this work. And then I'm gonna present you some results and finish by conclusion. So first, the motivation of this work comes from two things. First, I don't have to explain the first one. NLP, large language models, came out these last years. And the second is that we noticed that conventional stories for children are usually static. So we thought of combining both and allowing the children to generate stories by controlling story elements through playing with figurines in a contained environment. So like with characters that they know and like story words that they already read or are familiar with. So I'm not going to go over all the related works on story generation because there's a lot of them and all of them implement their work differently. But in the context of this work, we have some limitations in the field. For example, a lot of these works generate the story in a single instance. So you have like a input and then you get the whole story generated. But in our work, we want to generate the story incrementally, so step by step. Second, a lot of these works used older sequence to sequence language models, which we also experimented with, but didn't get good results. And lastly, a lot of these works generate stories in like a genre, but for our work, we want to concentrate on like a specific environment. So let's start with the data that we used. First is the book series dataset. As we said, we want the environment to be familiar to the child. So we had some criteria to choose the book stories from, and we finished by choosing The Tale of Peter Rabbit by Beatrix Potter, which is available in open source libraries. After pre-processing and splitting it into sentences and removing dialogue because we concentrate on action-based narratives, we get 745 sentences with a mean of 15 words per sentence. The second dataset is a verb dataset that we collected ourselves. So the motivation is that we wanted to focus on character, and character-object interactions because those are the figurines that the child is going to be playing with. So depending on that motion, we want to translate that motion into an NLP text. And over FrameNet, which is a lexical database of English based on word semantics. So each frame would have a meaning, like assistance here. And in each frame, you have lexical units, which are basically nouns and verbs. So we went through all these frames and selected the frames that we thought are suitable for interaction and motion, and took the verbs from those frames. So here, for example, a villain action would be, like the frames possible would be attack, or hostile encounter, or inhibit movement, for example. The result can be seen here. This is the word cloud of like the frames that we used. We also went through all the verbs and annotated them based on the motion attributes. So the direction of the movement, or the interaction, or the possible role of the character. So which frames are suitable for villains, or for main characters, or for support characters. And we got 120 verbs at the end that are annotated. So an example would be if the kid takes the figurine of the villain and brings it to a hero, a possible action would be Mr. Todd captured the hero. So after going through the data sets that we used, I want to go over the first part, which is how do we generate this character-centric representation automatically. Motivation is two things. So first, young children are usually influenced by fictional heroes in the stories, especially when they're deeply involved in the story. And second, the actions of the plot are usually driven by the character traits. So we propose a linguistic method based on attribute extraction to create this character-centric representation. The implementation flow of this pipeline is presented here. We start here with the books. We extract all the sentences, and then character by character. For every character, we get the relevant sentence where this character is mentioned. And then we split these sentences into simple clauses because it's easier than for the model to infer on them. And we filter out the clauses where the character is not the subject. And then using a common sense model, we get attributes for every clause. And then we transform these attributes and their frequencies into a suitable metric. The metric that we used is chosen based on an observation that we had. Basically, a lot of the attributes that we got, or some of them that were extracted, were not unique to specific characters. So you can see that they appear across all the characters of the story. So these attributes usually should have like a lower weight. So for that, we used TF-IDF, which is term frequency inverse document frequency. For those who are not familiar with it, it's usually used for searching in documents. So if you have a term and you search for the documents that have this term, TF-IDF allows you to like penalize a little bit the terms that appear across all the characters, all the documents. So we adapt this TF-IDF score. So for us, corpus or set of document is the set of characters, and the document is a character, and the term is the attribute. And here is a small example of how that looks. On the right, there's a character, Mrs. Tittlemouse, which is a support character. So if you look at scared and clean, scared has a higher frequency than clean, but gets a higher, but the clean gets a higher score because the clean is like a characteristic of this of this character in the stories. So after we have this knowledge graph or like this character representation, we move to the story generation part, which is pretty simple in a way. You get the instruction from the user, which can be adding objects or adding characters, introducing them into the story if the child brings this figurine into the scene. Or for example, if he does an interaction, then we use the verb dataset to sample one random action that fits this motion. And we translate it to a prompt, and we feed it with the context or like the history or like the story history to two LLMs. And we get two candidates, and then we have a ranker that calculates this character score and chooses the best candidate. So an example of that would be if the user changes the location to a forest, you get like this prompt, the character arrived at the forest, and one candidate would be this text here. And this is the writing phase, and then we move to the ranking phase. First, we have coreference resolution. So for example, he there is replaced by Tom Kitten. And then we used named entity recognition to get the character names. And then we split the sentences, or like the complex sentences, into clauses. So for example, here, the last sentence was split into two. And then for every sentence, we get two attributes, and we calculate the metric, or like the score, based on the knowledge that we had before. So now I wanted to move to some results. First, we tried to explore similarity and diversity. Similarity was done using BlueScore, where we compared the generated text to the original Peter Rabbit stories. And the diversity is using SelfBlue, where you just check the generated text and see how diverse they are. For the models, we chose two models. The first one is MPT 7 billion in a quantized form, so running locally on the CPU. And the second is GPT 3.5. And we noticed that, for example, the MPT generations are more similar to the books, but the GPT 3.5 are more diverse and actually closer to what a human writing would look like. But as we all know, in story generation, automatic scores don't really mean a lot. So we conducted a human evaluation survey with 21 participants that were asked to generate 2 to 3 stories each and answer then 20 statements about different aspects. So this is the result overview. I'm not gonna go over all of it, but I'm gonna point some aspects. For example, the system was good at the interactivity part in the all paragraphs kind of, but we noticed that the coherence drops as you advance into the story. The reason behind it, when we did the human survey, is that a lot of the time the LLM would like derails from the plotline, or sometimes forgets some characters or objects that appeared in the first paragraph, but then kind of disappeared and didn't appear again. For the other aspects, the results were generally good. We noticed that also a little bit of repetition sometimes, that the model repeats some sentences again and again throughout the story. But generally, the result was good. Also with the co-creation aspect, or sometimes didn't agree very much with the creativity part, because sometimes the model would force the story into like one direction that they didn't really want to go there. But yeah. So as a conclusion, we present stories. We introduce interactivity into the children's stories to allow user to control multiple aspects of the story. And we present an NLP pipeline to create this character-centric representation. And then we use this representation to try to guide the LLM into a paragraph that's, or into generating a story continuation that's more faithful to this representation. And the result stories were kind of engaging, enjoyable, and coherent. This is still the first iteration of this project, so we have a lot to do still. First, we want to replace because for now, this all runs into, for the people who came to the demo yesterday, it all runs using like buttons and clicks to simulate this motion, but we want to replace that with actually object detection, camera module, and we also want to add some other features like context summarization, because sometimes the context or like the story history is too big to give to the model. And we want to implement better instruction to the models, because now there's actually models that are specialized for storytelling. and we want to experiment with better prompts. So I think that finishes my presentation. Thank you all for your attention, and I'll be happy to answer any questions you have.
All right, thank you so much for the presentation. Any questions?
Thank you for the presentation. I think it's a really interesting topic. There's in one of the parts that you were talking when you had there was a scheme of the way that your model works. There was one part where you talk about a common sense model. What does can I ask a bit, because what does a common sense model do?
That model is BART Comet. You can look it up also online. It's a model that's trained on it's called like a knowledge, like common sense knowledge graph. And its role is you give it a sentence and it can give you multiple results. So for example, the one we used is X attribute, which is what a normal person would think of the subject of the sentence in that sentence. But there's also a lot of other common sense attributes that you can use. For example, you can use the object one. So what is the effect on the object of the sentence? And there are like a lot of other attributes that you can actually use. But for this work, we just use the X attribute, which is the adjective that can be inferred from that sentence on the subject.
Thank you.
Any other questions?
Hi, thank you for the talk. I'm just wondering, in terms of evaluation, what are your plans? Also because you're doing this for children, are you planning any evaluation with the readers? Hopefully.
Yeah, I think we have to at one point. Like I said, this is still like the first iteration. So we just tried it with like people in the field of CS or people around like the chair. But of course, if we're gonna at one point actually use it somewhere, we have to like test it with children and also test the ethical aspect of it, because as you know, like we are in a very closed like environment. Like the actions that we have, like we sampled before, so like the LLM can't really like go into like bad directions per se, but we still have no actual control over like what comes out, and that's also like one aspect that we have to like really question.
Great, let's thank our speaker again.
There's one speaker that has not come forward. So if you're presenting in this session and we haven't talked yet, please come to me, okay?
Right, great. And now we're passing on the mic to John Key Lim for the next talk.
Thank you, Maya. It's wonderful meeting you all. Good morning. I'm so excited to be here at Jönköping, Sweden, to kind of present this work on relational dynamics and human AI co-creative learning. I'm John Key Lim, an assistant professor of strategic design and management at Parsons School of Design and New School, along with I'm a doctoral student as well at Aalto University. I'd like to extend a special thanks to the ICCC community for hosting this work and creating this space, and Jönköping University for making this to work. So one of the aspects of the kind of work that I'll be talking through is about the introductions and backgrounds of this work, focusing on the methodologies and the results and some of the conclusion and future work to come through. And this topic has been something personal and important to me as coming from an art and design educator. And then throughout the history as an arts and design education, there have been a lot of different medium has been used in the past. But now with the latest technologies and computational creativity has seen a lot of these autonomous computational methodologies. And the key question that we ask as an educator is that how does these tools and using in the development stage of creative professionals, will that create a creative dependency? And the aspect that have been compelling to the research to kind of look into has been the framework of computational co-creativity. So Now, this is not a new concept. So there have been a lot of different types of computer supported tools and others exist. And on the other side, we have a computational creativity that is much more with systems that produce creative artifacts autonomously. So the computational co-creativity framework has been very useful to investigate these notions of not creating a dependency in these tools. And of course, within this, the key aspects of notions of initiatives, and then has been that where the initiative takes place has been looking at task, figures, and outcomes, and then how the computational systems, the human agents, how are they taking proactive roles in it? And then as we look into the creative capacity itself, existing research has looked into specific aspects of creative ability, such as lateral thinking and creative emotional reasoning. What this research is doing is, as an art and design community is coming from much more of a social cultural perspective on creativity, and also we're applying some of the learning theories along with it as we examine the impact and future implementation and development of systems. So the aim of this study itself is kind of trying to develop methods for understanding the perceptions of relationship between the users and the AI. And it'll kind of start to understand what are some of the emergent categories and perception and categories about this relationship, or is there a way that we can kind of describe these ideas? So we created this experimental exploratory experiments using both reinforcement learning and imitation learning, and as a human participants engaging in the creative problem solving. So one quick things on the background itself, as we talk about the notions of creative capacity, is building on this idea of from a much more psychological perspective, the ability to make something new and useful. And then especially kind of we're coming from much more the social cultural background, and we look at a lot of different factors that kind of emerge in the system to understand what does it mean to make something new and useful. And then that ability to make a new and useful and is happening both in an intrapsychological level, how an individual have concepts and ideas and debates and those activities are happening. Along with it is happening with peers and others. How the exchange of these ideas and things can also evolve into something that are perceived as new and useful by their peers. And then how can we measure that? How can we understand that? Is we're using an activity theory that is specifically looking into understanding an environment as a system where that specific object has been trying to be met by the people and the participant there. And we're looking at the actions, what kind of things that people do and say and things. We're kind of capturing those aspects as a unit of analysis. This work is built on to some of the previous work that me and the research colleagues have been kind of looking into, focusing on establishing the AI itself as a relational artifact in creative learning. And we've kind of done that in a more physical environments. And this study is actually kind of going to much more the virtual environments at the same time, specific focus. Methodologically, we're going through what's considered in the design research called a research through design. The making is a huge component of understanding new things, understanding the ideas and conceptualizing, and then much more mixed method research methodologies. Research participant for this exploratory research, we bring in the 15 human participants with a very diverse ethnic backgrounds. And then based on our background interview afterward, we did notice they have a general familiarity in like a virtual environments and gaming environment, along with the familiarity with like topics like with artificial intelligence, but not necessarily on like a reinforcement like training techniques, because those things do affect how they play the situation if they understand that this is a reinforcement related environment. So we created an experimental system using Unity in a virtual environment for creative and collaborative problem solving, where the agent itself, it's a machine agent here, here on the little red box here, is able to actually learn from the behavior of the human agent. It is co-creative in a sense that the objective is aligned, the objective that has been told to the human participant, and the machine agent is the same. It is a mixed initiative in the sense that they can take an initial action to solving the problem itself. Now, it does lack the communicated components. What the human participant end up doing is interpreting what's happening situation. So there's a lack of communication, but this is kind of situated the work itself. There are some of the design choices that we made that can foster some co-creative learning. We're explicitly kind of going with the character design of the AI to be same as the character design of a human agent in the virtual system. And the simultaneous learning is happening between the participant and machine agent using the reinforcement learning that is using the Unity ML agent package. One more thing about the environment. So we created 2 different scenarios within the system. One is a scenario 1. In this case, the 2 red boxes are the agents, the human agents and machine agents are populated in this space. And then the blue sphere is a goal. And then you can kind of see the first scenario is quite obvious to the human participants, able to kind of navigate and solve this problem itself. Second scenario is a little bit more tricky. So second scenario, you're populating this room. There's no obvious solution for human participant to go forward. Machine agents is a little bit different because it's not really kind of building on the visual perception per se. It's kind of going through the more rote randomization, reinforcement learning. These kind of techniques can lead to opening the secret door, and then that secret door that's where the goal existed. These 2 different scenarios has been kind of useful to think about what are the factors that goes into doing a creative problem solving and what relationship they emerge from those. So, okay, so all these environments and theories, how does it actually work? So in the sessions, we start by explaining the goal to human participants that their goal is to hit the blue sphere. And then participant reach the goal, it gets 1 point on their own. If the AI agent reach the goal, it gets 10 points. If they reach it together, simultaneously, that's 20 points. So you can see we're already kind of built in to do the work, to go about and do the activity itself. Each round is about 2 minutes. They're told to kind of learn from each other, and the machine agent is learning from them. And after the 2 minutes round, the participant engaged in a 2-minute semi-structured interview to kind of reflect upon what happened in the session. At the same time, when the interview is happening, we have our research team going through the reinforcement learning processes of kind of updating the agent for the next round to be like a little bit more knowing what's going on. So there's aspects of reflections and learning happening simultaneously. After that interview, then 2-minute session, the environment's refreshed with the policy reinstalled into the machine agent. And then for each scenario, there was 5 rounds happen. So total 10 rounds per participant. So 5 rounds for scenarios, and then 5 rounds for the second scenarios. So reinforcement learning is just a really quick recaps on this idea. There's a training mode, and also that there's a game mode if you're using the Unity ML agent. Training mode is like when the agents engage in a specific different types of reinforcement learning techniques. So they is able to kind of optimize this learning based on the reward and penalty that we prescribe into. So some of the inputs that go into the reinforcement learning for us is the agent's observation. So where the positions of machine agents relative to the environment itself, position to the goal, the sphere, along with some of the raycast data. And then the action itself is relative to the position within that environment, what action they should take to get to the optimal situation, up to the environment. Agents reward, as we gave positive reward for reaching the target sphere. We also kind of built in negative points as well, every time when they're hitting the wall and not really reaching it. And also if they are unable to solve the problem at a certain time, we also kind of give a penalty trying to let the machine to kind of get going and learning instead of being stuck in a corner itself. There's also an aspect called in a Unity package, ML agent package, there's a thing called curiosity that is a kind of rewarding the agent to kind of record and learn from and encouraging the agent to be able to do more things. Imitation learning is also the component we use for the first scenario, where the machine agents learn from then actually how human agent was solving that problem itself. We implemented it as scenario 1 to kind of facilitate their learning to be more fast. So with that, I'm understanding that there's a time limit, so I'm going to go into the results itself. So based on these trainings and based on these learnings and activities, what are the things that we have found? But there's 2 kind of main categories of thoughts came out. The categories of relationship come out. One is instrumental, the other is relational. Instrumental dynamic is really a machine. Humans are using the machine as a tool. So they perceive as a to fulfill my objective, I'm using this AI, regardless of its capability, is a kind of I'm going to use this to get there. Relational, on the other hand, is more I'm learning with the AI itself. one of the kind of the behavioristic the tendency that we start finding is that the naming and talking is oftentimes we're seeing the human participants start calling it and then ascribing genders and other things as kind of something that's very prevalent when it comes out. Also, when they start entering into the relational dynamic, sometimes they become very indifferent to the point of the exercise. Like, what does it mean to like maximize a point? They start caring about those. They're actually more interested in the behavior of the machine agent. And then within the relational dynamic, there's three different things has emerged. One is more paternalistic, that is like more like a pet and the parents and the child types of dynamic. They're kind of forcing it. They express remorse when they're not following through. They find joy when they're achieving. There's an antagonistic that is like, I'm in competition. I don't trust you in this dynamics to happen. To much more of an empathetic. Hey, you're my colleague. We're both stuck in this environment that we don't know how we're going to solve. So we have to figure this out. And I'm going to actually let you to take the initiative in solving this problem. And I'm going to learn from you and actively engage in that. In terms of creative learning itself, well, we start finding that there's an association between the actions in the instrumental dynamics is consistent more with the interpsychological learning dynamics. And then that's like and they're engaging in that dynamic, they're testing and combining, exploring new strategies. Actions are relational dynamic, of course, is more interpsychological learning. They're verbalizing their idea, trying to talk to, looking at the reactions in others. It is important to note that this co-occurrence of activities is we cannot say at this stage to be conclusive proof that these learnings are happening because these actions are happening. There's limitations in our methodology to kind of make that claim yet. One of the key aspects of it is the dynamic fluctuation. That is that throughout these 10 different rounds, certain dynamic emerge in their relations with the AI, but that is not always constant. Based on how they perceive from the human agent, from the human participant to the AI agent, perceived commonality between the human participants and the AI has kind of led to different types of dynamics along with the perceived challenge level, how difficult the challenge is at this stage. Those things really kind of affects what types of dynamics what types of dynamic can go in, has emerged from the interaction. And one of the important things that we start finding out is that the difference in initial conditions. So people with different backgrounds and knowledge and perceptions in AI was entering into the scenarios, entering into this empirical study, kind of emerge, they start with the different stages in their relationship and move on forward. There's no such thing, once they get into more relational dynamic, the people stay in the relational dynamic. It's kind of hard to de-anthropomorphize an AI. I think we kind of find that pattern. There's no such thing as a superior dynamic. Every dynamics that we found has been useful in its own way of encouraging different types of behavior. And along with this notions of uncanniness, as they had difficulty describing their relationship with AI, especially in those semi-structures interview. And I think that might have to do with as they're jumping between the instrumental and relational dynamics. So there might be something there that can be worth looking into the future research itself. What are some of the limitations and future work we can focus on is, of course, this study has a lot of limitations in terms of how the perceptions of relationship has been one directional. Interpretation of these actions are very contextual. At the same time, I think some of the things that really came out nicely during the review session is how can we understand different types of tasks, maybe much more related to a different relational dynamic. So those are the kind of work that we want to kind of look more into.
Thank you so much, Junki. Very interesting. Are there any questions?
Hi, thank you so much for the talk. I'm just curious about one thing that you said about the kind of psychological levels of it and the participants looking at the reactions of the AI. And I wonder what you mean by that, like how they were perceiving the reactions of the AI.
Perceiving the reaction. So in the interpsychological kind of learnings, as we would do in human-only classrooms, one would say, I'm interested in what my peer's doing. or I'm going to do something, I'm going to see what my peer are going to say. Focusing on that is, I would consider as a key aspect of interpsychological creative learning activity. Like what I do and what the others are going to do is important. So in this context with now human and AI agent, a human participant was very much paying attention to, based on what I do, I'm going to try to solve this problem by touching the yellow square. Is doors going to open? What's the AI agent going to do? They're specifically focusing on those behavioral aspects of the AI agent in that context. Does it address? Thank you, Murray.
We have time for one more question.
Thank you. Thanks for a great talk. I don't quite know how to formulate this question. It's a bit technical. In your very early diagram about learning, the creative learning one on the left-hand side, you had a cycle there, which is kind of describable in terms of Boden's theory of creativity, right? But there are two ways that the learning could have been taking place. They could have been taking place by changing the way the program explores the conceptual space, or they could be taking place by controlling, transforming the conceptual space, right? You see the distinction, yeah?
Yes.
What do you think is happening in your program? In my perspective, it looks as though it's the former, so it's just exploration, the method of exploration that might be changing, because there's not much to learn about the conceptual space. Am I wrong?
Thank you. I think the Boden's framework is so useful and so catchy, but as I'm sure many researchers like, it's really hard to operationalize. In the context of this research, how we perceive was what solutions are possible to solve the problem. That would be both combinatory and exploratory. Coming up with a totally new solution to approach it would be the transformative. So for instance, not by choice, but there's a human participant did learn that you can jump as you get to the certain wall in the second phase in the scenario 2. I would consider that as a transformative. The rule did not exist, but human participant kind of figured it out how to make a jump to get to that. But we were really in our analysis stage, and I talk about it in the paper just a little bit. At the end of the day, the Boden framework was really difficult to actually make it into the theoretical to be much more the analytical tools within our research itself. Because I think part of it is our unit of analysis focusing on the action and then relating to the specific conceptual state. There was too much of interpretation by the human research our researchers kind of applying to that. It's like, at what point do we say this is combinatorial? At what point are we say this is transformative? And it was really hard. We wanted to push there and go there, but we just find that it's like, this is not, we're in a gray world. So
thank you.
Thank you.
Right, wonderful. Let's thank our speaker one more time. And now on to our next talk that's going to be presented by Manoj Deshpande.
Hello, everyone. I'm Manoj Deshpande, a digital media PhD candidate. I'll be presenting our paper, The 5 Pillars of an Action, the theoretical framework for co-creative artificial intelligence, written by Dr. Nick Davis, who's the first author who's not here, myself, Dr. Jeba Rizwana, and Dr. Brian Magarko. All right, let's begin by discussing the context and motivation for this work. With the advent of generative AI systems that can collaborate with users on a shared creative product, namely co-creative AI, has become prevalent. It is clear that co-creative systems will be a prominent feature in the future AI landscape. However, to develop a truly co-creative system, we need cognitive theory guiding co-creative AI. But the current prominent paradigm in cognition is that of information processing theory of cognition, which views cognitive agents as making sense and acting based on goal-based planning. But co-creation is inherently improvisational, dynamic, open-ended, and interactive. So the information processing theory really needs to be supplemented for it to be applicable to co-creative systems. The cognitive science theory of inaction is particularly well suited for this study of co-creative AI. Inaction views cognition as emerging from the interaction of an agent with environment and other agents in the environment. What we are arguing is that the theory of inaction can be used to design, evaluate, and describe co-creative AI systems. To this end, we will be introducing our framework, which is based on the 5 pillars of inaction. All right, let us look a bit more detail in as to what like enactivism is. So embodied cognition, which is especially enactivism, argues that creative process emerge from an organism's sensory motor activities, interaction, and environmental engagements, emphasizing the intertwined nature of perception and cognition and action. And within this, there are 3 kinds of enaction. The first one is called the autopoietic enactivism, which really is based on the biodynamics of the living system. This version of enactivism has no distinction between, let's say, mental or non-mental biological processes. The second one is called the sensory motor enactivism. This basically involves cognitive agents actively engaging with the environment to create a dependence between the action and the sensory states. We can think of this type of cognition or cognition as thinking by doing. And lastly, radical enactivism. This rejects the idea of mental states entirely. This views that cognition can be analyzed as an interplay between the biological, sensory motor, and the social like interaction that takes place. So while the inaction and enactivism encompasses a broad spectrum of ideas, it's still not applicable to co-creative AI because we need a framework that distills it down to interaction and social like sort of causes. Participatory sense making, the socio-cognitive framework by Dieger and Di Paolo, is exactly that. What it says, this is the participatory sense making primarily draws its concept from autopoietic enactivism, but there are some like sort of theories or concepts from the sensory motor enactivism as well. And it is formally defined as the coordination of intentional activity in interaction, whereby individual sense-making processes are affected and new domains of social sense-making can be generated that were not available to each individual on their own. Within this like PSM in a framework, the socio-enactive cognition has like 5 critical concepts, which are what the 5 pillars are. The first one is autonomy. This is basically saying that we are self-autonomous as cognitive agents and we maintain our identity in a social interaction. The next one is sense making, which basically is the process through which an agent can make sense of an interaction through this sensory motor feedback. Next is embodiment, which focuses on the importance of having a physical body and like how cognition is basically grounded in bodily experiences. Then emergence, which really denotes to the idea that complex meaning can emerge from simpler interactive elements. And lastly, experience, which refers to the cumulative history of my previous experience, which is affecting my current interaction and also like possibly influencing my future interaction. So our proposed framework is based on this enactive theory and applies these 5 core concepts. We describe a fully enactive co-creative AI system as when a human and an agent collaborate on a shared creative product, maintaining on a shared creative product where the autonomy of the user and the agent is maintained and the meaning is built through interaction, coordination, communication, and feedback. The agent and the user engages in sense making and participatory sense making to understand each other's creative intentions and enact or bring forth meaning in the environment. Both the users and the agents are embodied with interactions constrained in their and afforded by their bodily presence. Lastly, the agents, no, not lastly, but agent engages in the improvised interaction to yield emergent interaction dynamics. Now, lastly, the agent remembers its experience, storing the interaction history and utilizing that to guide the creative like sort of interaction that it is having and having a creative trajectory to do so. All right, a system cannot always be a fully inactive system, and it is always on a spectrum of, let's say, a highly inactive system to a minimally inactive system. To aid in analyzing and describing the features of co-creative AI systems, what we've done is we've broken down this pillar into three classifications: a full, partial, and none. For the analysis purposes, the fully inactive system are rated as 3, partially inactive system are rated as 2, and none is rated as 1. Next, I'll describe each pillar within this like broken down like sort of concept. So in this context of co-creative AI, autonomy refers to the ability of agent to choose its own creative actions and determine when to contribute in a co-creative activity. Within this, a fully autonomous agent takes the initiative and can choose its creative action. A partially or semi-autonomous system, agent does not take initiative but chooses its own creative action. And a user-directed system is a system in which the agency completely lies in terms of like with the user, and the agent just does what it is told to do. Sense making is the process of exploring the environment through the interaction, which basically involves like acting on the feedback that the user is giving. A fully sense-making agent regulates the interaction through coordination and feedback. This type of agent could achieve participatory or joint sense-making with the user. In partial sense making, the agent orients itself. So it is basically responding or reacting to users like sort of input, and can achieve like reactive sense making. And in non-sense making, the agent does not regulate action or on the feedback. This equates to a system just trying to follow a script in the interaction. Moving on, the embodiment refers to, again, how the agent uses its body and how its interactions are based on the bodily like presence. A fully embodied agent would have a virtual or a real body, and the actions are constrained and afforded by that body. A partially embodied agent, again, having a real or a virtual body, but can have a real or a virtual body, but the actions are like not based on the bodily constraint. This would equate to having like a static icon or like an animation, so on and so forth. A non-embodied system has no virtual character or anything to do. It represents the AI. Emergent system again rises from simpler interactions that the agent has. A fully emergent agent produces contributions that are strongly emergent, highly variable, spontaneous, and unpredictable, and cannot be deduced from the low-level rules or the algorithms that it was created with. A partially emergent agent produces weakly emergent contributions, and though they are unexpected and surprising, they can still be deduced from the initial rule set of the algorithm. And a non-emergent agent's interaction is completely based on script, and it does not improvise in any like circumstance. The experience category again is broken down into 3 parts. A fully experiential agent learns from all aspects of its previous interaction. Basically, it takes into consideration the entire learning history. A partially experiential agent has somewhat of a history and doesn't really like learn entirely. And a non-experiential agent does not use any of the knowledge from the interactive history at all. So this is our 5 pillars framework. It consists of all these elements. The framework offers a vision of what a co-creative system can potentially achieve. All right. So we applied this 5 pillars framework to analyze 20 co-creative AI systems. We used a convenience sampling where we used like we selected co-creative systems based on what the authors were familiar with. 3 researchers independently coded each of these systems and met with the 4th researcher to discuss these like sort of coding. We used a technique called as consensus assessment technique, which essentially is that we discuss amongst ourselves and reach a group consensus. And based on that, we recoded the system to reflect the group consensus again. This table shows the analysis of the 20 co-creative systems that we have. Dark blue is rated as 3, blue is rated as 2, and light blue is 1. So the results. A highly inactive system is typically scored 12 over bow, which is an addition of all the 5 like sort of scores. From our data set, we had Shimon, Google Gemini, ChatGPT, Google GitHub, GitHub Copilot, and Kobe as a highly inactive system. Usually in a highly inactive system, they are fully autonomous or semi-autonomous. They feature full sense making with feedback and coordination happening in the moment. The systems have partial embodiment or fully embodied. The actions of these agents are typically fully emergent and cannot be reduced to the initial like rule set. And these agents have somewhat maintained the interaction history, not entirely though. In a moderately inactive system, the score is between 9 and 11. And in our like analysis, we had 8 co-creative systems, and some of the examples are StoryDrawer, Drawing Apprentice, Lumina, Elysia. These systems typically exhibit a semi-autonomous characteristic. They feature a mix of full and partial sense-making processes. AI embodiment is moderately inactive, or it can be fully inactive also, sorry, embodied also. The contribution of these agents are a mix of like strong and weak emergence, and moderately inactive systems typically have partial or no experiential learning at all. And in minimally inactive system, the score is less than 9. In our data set, we found 7 co-creative systems that are like this. Some of the examples include Stable Diffusion, Creative Sketching Partner, Drocto, Poetry Machine, etc. In a minimally inactive system, typically the agent is semi-autonomous or user-directed. They feature partial sense making where the system reacts to user's contribution and acts on that. A minimally inactive system has low embodiment or no embodiment at all. The contribution of a minimally inactive system is typically weak emergence, with the exception of Stable Diffusion, of course. And they have minimum, like they have less history or like no history guiding their process. So based on these like sort of analysis that we did, we have identified like few design recommendation, which you guys can use based on the use case context. So based on the creativity, by designing co-creative AI, autonomy could be included in co-creation more like spontaneous interaction. However, future research is necessary to understand balance between AI autonomy and human control. The first talk, but anyway. We should also include explicit feedback. For example, this would help AI agent to like align itself more with the user like sort of the feedback mechanism. Ideally, we should have a bidirectional feedback on where it is. We should try and include a physical character or virtual character. This makes the interaction richer and helps the user connect with the agent more, as we've seen in the literature. When designing, we should be considerate about the size of the rule set and the initial like sort of condition. The better the rule set, the complex the rule set, the higher the chances of prolonged like interaction. Lastly, we should really have the interaction history. Experience is like lacking in most of the co-creator system, and we should really have a interaction history. We should consider adding a creative trajectory monitor to see what has happened before and like base actions based on that. For more details, please refer to our paper. Thank you so much for listening.
Well, this was super interesting. Thank you. We got some questions. You want to go first? Sure.
Hi, thanks for the presentation. It was an enjoyable experience to watch it. So if I understood correctly, there were multiple people assessing these systems based on these aspects, and then they reached a consensus, and then this was the kind of final score for that system, right? So I was curious, was there a lot of variance in these assessments? Was it easy to reach consensus, or were they mainly of the same opinion? For instance, if a system is fully emergent or only partly emergent?
Yeah, really good question. Thank you for that question. So initially because we were familiar with these systems, what happened was we were going off based on what we knew, and that created a lot of like discrepancy in terms of like, especially in emergent category, because we were like, oh yeah, this system is like fully emergent because I know I've interacted with this system. But then we realized that doesn't work and we really need to fix a publication. So we took a publication in which the agent was talked about, and we just based the rating based on that like published like material and not what has happened after the publication has been done. After that, I think we reached a group consensus like fairly easily, but there were a lot of disagreements because it was the first time we were coming up with this framework also, and then it was these like sort of discussions were where we refined the framework and the definitions of what these like individual things mean. So yeah, it happened both ways. Thank you again for the question.
Thank you.
Hey. Yeah, congrats on this. So I was curious about the highly anxious systems. So I think the only one that was actually embodied was Shimon, but you said that usually they are highly embodied. Like I'm just considering like Gemini, ChatGPT, were those considered embodied?
No. Really good observation though. So when we were talking about embodiment, this was a grid like detailed like sort of discussion that we had when we were coding also. Initially, we were saying that okay, embodiment means that there has to be a physical like body, like Shimon, and that would mean that there was no other like system that would really be like fully embodied. And then we discussed the idea that embodiment can also be expressed through text. Since just because it's text, it's not like I'm not non-embodied, because language itself is like a very embodied like sort of thing. I'm always using directions and like so on and so forth. So we were like debating about that as well. So then we came to consensus that no, we need to have a physical body. So what we eventually did was we rated this like partial embodiment like sort of thing, and then we assigned most. If you see our analysis also, most of the co-creative system is in that partial embodiment. But the hope when I was presenting is that more people will actually make it like physically embodied. That's why I did that. Thank you for the
Thank you.
Anybody else?
Thanks for that. My question is if it's desirable that all the features are the highest, or okay.
Sorry.
Yeah, and then, no, that's basically very succinct.
Yeah.
Yeah, and I guess a little bit of an implication of that is, have you measured what impact it has, each feature has on certain metrics on the co-creativity, like effectiveness and so on and so on?
That really is like the future work. That's the next step that we would want to take, is that now we have a theoretical framework. We've tested it with like 20 co-creative systems that already exist. We have a co-creative system of our own also, a couple. So we can use this now as a framework to test how, like, if we have a co-creative system with all like highly like ranking, like highly inactive system, how does it map to like other like user interface and like user experience metrics. But yeah, that's future work. Thank you.
Wonderful. Let's thank our speaker again.
Yeah. Yes.
And now I get to introduce to you Manoj again.
All right. Hello again. uh, so now I'll be presenting our next paper, which is reframing computational co-creativity from an embodied socio-cognitive perspective. This is written by myself and Dr. Brian Magarko. Let's get started. So collaborative creativity or co-creativity is an integral part of human existence, deeply ingrained in our daily interaction and essential for making sense of our complex and dynamic world. With generative AI technologies transforming industries and everyday life, the potential of collaborating with these like intelligent systems has captured the global attention. As these technologies facilitate novel human AI collaboration, it is crucial that we examine and define what is computational co-creativity critically. In this paper, we propose a new definition of computational co-creativity, synthesizing theories from human-computer interaction, embodiment, and social cognition. Uh, the aim is to refocus the primary concerns and challenges to address while designing the co-creative systems. The idea of envisioning machine as an intelligent system or a creative partner is the key focus of computational co-creativity, a subfield of human-centered AI. In literature, multiple terms have been used to describe the phenomena of co-creativity. Co-creativity was the term first used by Candy and Edmonds, and it is used to express the collaborative creativity between humans, computers, or both. Other terms include mixed initiative co-creativity, as described by Yannickakis et al. From a game design perspective, mixed initiative creative interfaces, as described by Detterding et al. From an HCI and system design perspective, and Centaur system, as described by Goldstein et al. From a healthcare research perspective. Like the various terms referring to what co-creativity is, there are several definitions of what co-creation is. Yannickakis et al. Describes co-creativity as the task of creating artifacts via the interaction of human initiative and a computational initiative. Davis et al. Describe co-creativity as when computers and humans collaborate to build a shared creative artifact. Cantasalo et al. State collaborative creativity is characterized by shared responsibility between the human and computational participant over the created artifact. Keremi et al. Define co-creativity as an interaction between at least one AI agent and at least one human, where the actions are based on the response of their partner and their own conception of creativity during the co-creative tasks. So from these elements, it appears that 4 key elements are fundamental to computational co-creativity: a creation of shared artifact, a well-defined interaction, an action-response cycle, and a conception of creativity by each participant. Although these definitions lay a cursory understanding of what computational co-creativity is, it still is unclear. For example, what does sharing of an artifact entail? Is it enough to have an action response cycle, or does the AI agent need to grasp the ongoing interaction? Or do AI agents and humans really have the agency to act on the conception of creativity that they have? Hence, we propose computational co-creativity needs to be redefined to align more closely with human-human co-creative interaction, moving past these like basic functional elements. Let me give a brief overview of theories and domains that we use, which are foundational theoretical lenses for the redefinition. Let us first look at theories from HCI. Based on Suchman's work, we can see collaborating with technology as a new human-machine reconfiguration that will help us achieve new agencies or possibilities of thinking, increasing our cultural imaginaries. Technology itself can be seen as a form of material semiotic figuration, which is a concept described by Haraway, which allows us to think of AI systems as an integrated extensions or collaborators rather than as a separate entity, forming a new cyborg for figuration. The underlying philosophy of these work is that of an embodiment. Durish describes embodied interaction as creation, manipulation, and sharing of meaning through engaged interaction with the artifact. Through this lens, we can argue that human AI interaction, like any other interaction, is contextually situated with embodied meaning construction. ID brings all of this together with his post-phenomenology framework, emphasizing how technologies are not merely a tool, but are integral to shaping our experience of the world. Now let us look at theories from social cognition and intersubjectivity. Similar to Suchman's idea of distributed agency, Hutchin proposes distributed cognition. According to this theory, cognitive processes are not confined within an individual's mind, but is distributed amongst objects, environment, and the individual, and the interaction between them. And unlike dualism, embodied cognition, especially in activism, argues that cognition arises from or is constituted by the sensory motor activity and the interaction with the environment. In other words, it basically says that we can't receive information passively and we need to actively engage with the environment. Dieger and DiPaolo's framework further define like socio-cognitive framework called participatory sense making, which is basically the process through which the embodied agents make sense of their interaction. This is an essential mechanism of all like human-human co-creative experience. Moving on, let us look at theories from creativity and improvisation. We can view creativity itself from this intersubjective perspective. As Glanevu defines, creativity is a complex socio-cultural psychological process that, working with culturally impregnated materials within an intersubjective space, leads to the generation of artifacts that are evaluated as new and significant by one or more people or communities at a given point in time. Glanevu further elaborated that creativity emerges from interplay between actor, action, artifact, audience, and affordance. Cantasalo et al. Adapted this to human AI co-creativity with her 5Cs framework, which basically views creativity as an interplay between collective, collaboration, contribution, communities, and context. Lastly, acknowledging that the improvisational nature of the interaction in open-ended creative tasks based on works of scholars like Sawyer and Magarko, who highlight the different kinds of knowledge necessary for being and improvising in co-creative activities. To gain an insight into the ever-evolving landscape of human AI co-creativity, we must tap into this diverse array of theories, frameworks, and fields of study. Together, they provide a holistic view of how humans, technology, and creativity intersect. So based on these lenses, let us now look at co-creativity. But before that, why do we need a new definition? Definition plays a pivotal role in defining and driving the research forward. As Buchanan highlights, definitions are not static endpoints, but are strategic tools in inquiry. They help researchers and collaborators establish clear direction of their work, fostering progress and innovation. So redefining co-creativity is therefore essential to create and steer the human AI exploration and provide clear sort of direction. We can offer fresh perspectives by combining insights from all of these theories and opening the field a bit more. Uh, it will also broaden the scope of the research while intertwining human experiences, technological advancements, and creative processes, and enrich our approach to human AI co-creativity. So in redefining co-creativity, it is essential to move past the basic 4 elements that we had. It is not enough to just have a conception of creativity. We need to have the agency to act on the said creativity. It is not enough to just talk about the action response cycle. We also need to incorporate the essential component of situated, collaborator, or participatory sense making. It is not enough just to talk about the interaction. We need to consider the nature of interaction, which is usually improvisational. Similarly, it is not enough just to talk about the shared artifact. What we need to talk about the process and the performance also. So based on all of this, we propose co-creativity can be defined as when humans and AI agents engage in an open-ended interaction involving continuous negotiation of creative agency through collaborative sense-making to create a shared artifact or performance. Let us now look at each of these components and their definitions closely in relation to the theoretical lenses and the established frameworks in co-creativity. So, co-creativity involves a dynamic and adaptable exchange between humans and AI, where creative journey is not pre-scripted. This is based on improvisational theories and concepts of post-phenomenology. Particularly, it draws from Sawyer's improvisational approach to creativity, characterized by emergent nature that allows human and AI to spontaneously offer new ideas. It also aligns with Magarko's improvisational HCI framework, which stresses the importance of flexible real-time responses and in the creative process that are informed by diverse forms of knowledge. ID's idea of multi-stability, the notion that technology and meaning and function varies based on context, is also applicable here. In co-creative systems, AI roles and creative processes might depend on the field in which the AI is being utilized. The idea is also captured by various frameworks like Nakakoji, Myers, and Kantasalos, who have proposed various roles of AI in creative tasks, ranging from supportive tools to being equal partner. Co-creativity involves fluid sharing and negotiation of creative agency between human and AI. This is based on reconfiguration, distributed cognition, and cyborg figuration theories. Based on Suchman's idea, co-creativity can be understood as a novel interaction between human and AI, capable of extending our collective capability. In alignment with Hutchins' distributed cognition, both AI agents and humans can actively contribute and guide the creative process. Furthermore, Haraway's concept of cyborg emphasizes the integral role of technology in our lived experience. Within co-creative system, this translates to perceiving AI not as merely as a tool, but as a collaborator and an integral extension to ourselves. The Dettering-Attell's interaction frameworks of ideating, constraining, and producing mirrors these principles also. Creativity arises from collaborative interaction and collective sense-making. This is based on most foundational theories, but it majorly draws from participatory sense-making, embodied interaction, and intersubjective creativity. In this framework, human and AI actively interpret and respond and co-create meaning with creative domain, resonating with Durish's concept of embodied intersubjective meaning construction. According to Glanevu, meaning and ideas evolve through interaction within the shared space, demonstrating the dynamic and intersubjective nature of the creative process. The role of bidirectional communication is also highlighted by interaction framework by Gazelle and Rydell and Meher and Rizwana. It ties into the theory of inaction and social cognition. Lastly, frameworks like CSM by Davis et al. And OCSM by Deshpande et al. Focus on the quantifying sense making and offer a way of capturing the ongoing interaction as well. So next, I'll present a case study of our co-creative project called Luminae, which provides a practical application of most of the things in the new definition. Luminae is an interactive installation that features a virtual agent that is capable of improvising movements in collaboration with human participant. It has been in development for several years. The focus of Luminae's current research has, however, shifted from providing casual interaction to a more specialized study of improvisational process in dyadic dancers involving professional dancers. The latest design utilizes something called as hologauze, a semi-transparent mesh fabric inside a black box like sort of theater, which let us display Luminae and make it seem like holograph. Currently, Luminae comprises of 5 distinct software modules and which is broken down into specific function, and it has perception, description, learning, transformation, and selection, which are slightly like self-explanatory. Let me show a brief clip of our recent live improvisation dance performance of Luminae with trained dancers. The show was held in Atlanta and Georgia, and more than 250 people were in the audience. Here's a brief clip. All right. For more details, please refer to our paper. Thank you for listening.
All right, thank you so much. What a great clip at the end there. We should have included that in the conference, a live performance. All right, any questions? We must have some questions.
It was a great presentation. I want you to improvise an answer to this question. What about those creative processes which are not performative? Not all of them are performative.
Yes.
Like this example.
Yes,
Would your
yes.
framework still apply?
Yes. The idea was to include, when I include performance, like I'm including that in a broad like sort of way. We were trying to focus that we should also include creative processes and not just focus on the end product. Like the 4-piece framework, there are 4 things that we can think of. So process is also an important thing. And most of the like co-creative endeavors have a process, at least if not a performance, and that process itself can be performative. That's why we included performance instead of process there. Yes.
Wonderful. Any other questions? I think Ollie.
I was hoping you still have your slide up because I wanted to us to look at the definition again. From memory of what it said, it had a lot of factors in it, and I
Yes.
just wondered if it was like over constrained, and I wondered if there was the potential to sort of examine that definition. Oh, you've got here we go, photo of the. No, look, I won't go right into it, but I just wondered if it was possible to just examine that definition in contrast to something that had fewer constraints and consider where that sort of boundary lies between what you define as co-creation and what you wouldn't.
That's a really great question. Thank you for that. We haven't done that though, but I would really like to do it. Like examine a system that is widely considered as co-creative, which would not meet our definition of what co-creative systems are, and then examine it with something like Luminae and compare. But honestly, I haven't seen any co-creative system which doesn't meet these like sort of criterias. Most of them don't improvise, agreed, but most of them do. Like and if they're not, we should strive to like make it improvisational and open-ended because that's what creativity is all about. But yeah, that would be like a future like research. Thank you for that.
All right, wonderful. Let's thank our speaker for 2 amazing talks. All right, we have our final talk here by Stephanie Hood. All yours.
Is this on? Yeah. Hello, hi, I'm Stephanie, and I'm visiting here from IBM Research. Excited to present work by my team there, who mostly focuses on human-centered AI topics. And I'll be talking about our work studying the use of an AI agent in a group brainstorming conversation. So the work of our paper was done in the context of a program of research where we're investigating several human AI co-creation topics, including AI in group conversation, reactive versus proactive AI in the context of that group conversation, brainstorming within AI as an example use case to explore human AI co-creativity. Excuse me, and mixed initiative frameworks where co-creative actions and action sequences are identified and used as tools for analysis. And I have to stop and say this is an area of particular focus of the first author of the paper, Michael Muller, who was sorry not to be here to join you today. He has presented here in the past, I think in 2020 and 2023, and really enjoys this community. We built a prototype to explore these themes. It is a large language model powered AI Slack bot called Koala, and it appears in a Slack channel where human group conversations can take place. And it's represented there as an app. And we gave it the Koala picture and name. So Koala can be configured in our system to behave reactively so that it only responds when addressed. And you can see in the example here, someone says, Koala, what do you think? And then Koala responds. But without having its name mentioned in some form, it would otherwise not respond in that configuration. And it can also be configured to contribute proactively without being asked. So in this example, the group is having you'll see later, a brainstorming discussion on a topic, thinking of ideas. And no one mentions Koala's name, but Koala jumps in and put some emphasis on the idea that sound quality is crucial. So in that case, it was contributing proactively. So we use this prototype to conduct a user study to explore group brainstorming with an AI agent. And for this, we held 6 study sessions, and each session had 3 human participants. And those participants were, we recruited work colleagues who already knew each other. And this was for some practical reasons. One was so that we didn't have to do introductions. And another was that so they would feel comfortable working together in a Slack channel, communicating ideas, so there wouldn't be any barriers. And so that made for a total of 18 participants. And we did recruit them from the larger employee pool of IBM, which is large multinational company, as you know. And they have a variety of job roles at our company: marketing, engineering, videography, and design. So we sort of recruited for a variety, but all professional job roles. So each study session consisted of 3 brainstorming rounds held in 3 different Slack channels. And communication in those channels happened only through text in the channels. Participants did not also speak to each other, for example. In each channel, a different AI condition was present for each round. So in the first round, we had only the 3 participants addressing a brainstorming topic, and I'll tell you how that process goes as we move. So they were just slacking together to develop ideas. And in the second round, the 3 participants were joined by a reactively configured Koala agent so that it would contribute only when asked. And in the third round, the 3 participants were joined by the proactive version of Koala. So it would still respond when asked, but it would also sometimes contribute, many times, contribute proactively. And the order of these AI conditions did not vary across sessions. When we did this really so that we could have a successive gradual acclimation to the brainstorming task in Slack, first getting used to brainstorming in Slack together in a rapid, not asynchronous as Slack is often used, but like synchronous way. And then to having an agent presence, but one who would only respond when demanded, and then finally to the more active version, the proactive agent. In each of these rounds, a different brainstorming topic was put out for idea generation. And these are represented as A, B, and C, as you can see here. We did choose these to be topics that would be sort of familiar and easy to work with for our professional community of users that we had recruited. So for example, topic A, how can we improve hybrid meetings for remote participants? Something everyone at our company experiences as a challenge. So people had ideas. And in this case, the order of these brainstorming topics were counterbalanced across all 6 of the sessions. In each round, a facilitator assigned the topic and initiated a 3-minute kind of intense generation of divergent generation of as many ideas as possible as the participants could think of as solutions for the topic. And then when the time was up, told the participants it was now time to discuss which 3 ideas they'd like to propose as final. So that is the way we had the target end of the brainstorming. And after each round, participants filled out surveys where they reflected on their experience in the session and successively compared it to their previous experience. And we also exported the transcripts from all conversations of these sessions. And we'll go into some more details on that. I'm going to just first start with some extremely high-level results from the survey data. There were 2 things were extremely clear. One was, surprisingly, I was quite surprised that not one of the 18 participants said they preferred brainstorming just together without the AI in the first channel, which I found surprising. Again, this is a very particular task context. But after that, there was also an overwhelming preference for the way our reactive AI behaved for them. And the most commonly sort of nuance in their comments talking about why they liked working with AI overall was that if there was a lull in ideation, it helped them to get unstuck. And a lot of people use that exact word, unstuck. Many people said they saw potential in our proactive AI, but it was far too proactive. It was try as we might to get it to settle down. It said too much. It said it too quickly. It sort of reminded you of sort of a person in class who doesn't give anyone else a chance to answer. So it could be overwhelming. It's been fun hearing the talks in the session today about different elements of user control and other frameworks to evaluate in. So we definitely plan further work in how to, apply the right knobs or balances in the defaults to get a better result. And we'll be doing more work in that area. But actually, the primary focus of the paper that we contributed to this conference was on analyzing the transcript data from the brainstorming rounds, where the humans and AI collaborated to choose those 3 final ideas. So to do that, we needed a coding scheme. So we started by converting the conversations into spreadsheets where contributors in the Slack channel that included facilitator, 3 participants, and the AI were each sort of assigned a column, and any Slacks they contributed to the conversation. We, converted to text, including representations of any emojis, into these spreadsheets, sorted by timestamp, going from top to bottom. And then we laboriously tagged all of these. 6 researchers agreed on a set of brainstorming actions and we read all of the transcripts and tagged individual entries, again, from the original conversation as either task instructions from the moderator, proposition of a new idea, refinement of an idea, supportive, either emojis or text supporting an idea in the form of the plus, negative comments, saying, well, maybe that's not so good about the idea, or sort of a thumbs down approach, and also decisions on the final ideas. 5 minutes? Oh, okay, fast. Okay, so armed with these coded transcripts, we were able to analyze the results. And the general questions we were thinking about were, what was the impact of AI on brainstorming with humans? And in some of our questions were, would AI contribute ideas? Would any of those ideas make it into the final selection? Does AI refine ideas? And central question in the paper, how does an idea become final? So to answer these questions, we worked to analyze the origin and shaping of ideas in a few different ways. And one of them was by visualizing the coded sequences to see how ideas go from being proposed to potentially becoming final. So here you see different colors, like new idea represented by bright green. Light green is the refinement. Gray represented the pluses or minuses. And we could then visually kind of track ideas with the lines connecting them. Each new idea had an independent ID. And you can see on the right, that's a visualization. This is actually one of a reactive idea versus a reactive session versus a proactive session. And all of those many, many green dots on the far right, those are from the AI. And you can see how it was much more active than the people, and it could be overwhelming. So this is another kind of visualization, a Sankey diagram that is actually a accumulation of all of the conversations, of the codes from all of the conversations in both of the AI condition sessions. And we'd just like to use this to illustrate some answers to some of our questions. So one, did the AI contribute ideas? Yes, it definitely did. In fact, it contributed 73% of the ideas produced. And did any AI initiated ideas make it into the final selection? Yes, they did. In fact, consistently across both of those 2 AI conditions, even the one where it had so many ideas in proactive and fewer in reactive, it was pretty consistently kind of a 1 in 3 relationship. 33% of the time, one of the AI's ideas ended up as final. Did the AI refine ideas? Yes, it participated in the plus and minus actions and refinement, which were present in 78% of all final ideas. And as to one of the main questions in the paper itself, how does an idea become final? Well, no single characteristic or sequence of events led to a particular idea always being final or non-final, but we did observe some correlating factors. So first, there was a tendency for final ideas to be decided early, 69% by the 7th step of an action sequence, whereas non-final often took longer, even up to a series of 12 actions. Another factor, involvement by at least one human and the AI together, more than doubled the likelihood of an idea to become final. Only 10 ideas were chosen as final after AI actions alone, and only 4 after human actions alone. So I'll just briefly touch on mixed initiative frameworks at the end here. We were inspired by them. Spoto and Olenek, if I'm pronouncing the names correctly, introduced the concept of actions that could be performed by either a human or AI, and they proposed the action vocabulary in the left column. And then other researchers, including Michael Miller, again, the first author of this paper, reused this idea for different domains. And in Koala, we attempted to create an action vocabulary that you saw we used to tag the transcripts with. We noticed that our vocabulary was well aligned with prior work, but we were surprised in a way that we needed only 5 actions compared with the others. And we suspect that each application or work domain may in fact involve a different subset of actions. So our work was inspired by the 5 C's model that I heard also mentioned in the previous talk of Cantasolo and Takala. We propose a framework that we call the Chow model that emphasizes, as a derivative of that emphasizes dynamic exchanges that often take place in a group conversation. And just to wrap up quickly, we were excited that it turned out that AI proved to be a valuable partner, we thought, in the brainstorming exercises, in that it did originate ideas that were selected as final, and it made refinements to others in ways that made them more likely to be chosen as final. There is, of course, a lot of work to be done in terms of wrangling in the proactive version of the AI. We do see potential in it. It's a lot of work to continuously ask for ideas from a human or AI, but we have a long way to go before we find a way to do it conversationally that didn't overwhelm people. But it's been fun learning about some ideas about that in this session. So more details in the paper.
This was super interesting. Thank you so much. I have a quick question.
Yeah.
So one of the things I really like about this paper is that the mechanism you used seems to be generalizable to analyzing other systems. So in particular, I was thinking whether you considered using it to analyze systems that are geared towards creative applications like storytelling or lyrics writing, and or whether you think this would be valuable.
I think it could potentially be, the types of example applications that we focus on being an industrial research lab tend to be things that are a little closer to what could be applicable in the sort of business community, or for example, design thinking exercises and things go on in teams, within corporate environments. But I definitely think that that's an area of, great interest and could be applicable. It's just sort of our example case was sort of guided by our corporate context.
Yeah, that absolutely makes sense. Great. We got some questions. Okay, excellent. 1, 2, 3.
Thank you for the great talk. I actually wanted to just dig a little deeper about why do you think the AI is so helpful? 2 points related to that. One, is it true? Did you observe that the AI is more valuable if the brainstorming session goes longer? So is it that, people have a lot of ideas in the beginning, but slowly they start getting stuck? And the second point is, did you compare adding a new human versus adding an AI agent?
I like both of those ideas a lot. We did not do either of them. We just had this very constrained task we had a time limited brainstorming time frame and this target of the 3 ideas. So in that way, it's not very realistic to how, say, a group who is, if we were doing a more realistic, it was a controlled task rather than a example of a real one, which I think could take place over many days and be asynchronous and have much longer lengths of time. So I like both of those ideas. And I think they would yield different or potentially other results. Even in the 3-minute time span, I suspect that even in a longer session, it might be useful having the ideas that the AI provided. People commented that they either they gave them a new idea, or in some cases, they made them feel reinforced on an idea that they had. And both of those things seemed useful to this idea of maybe getting unstuck or thinking which ones were more important.
Great. We had
really cool work. Thank you. I'm especially happy to see some
sort of protocol studies style work in this space. I know exactly how laborious that is.
It
so
was, it
yeah.
really was. When you talked about a longer study, my first thought was, oh no, that would be a longer transcript.
Yeah,
So-
protocol analysis is rough. So I wanted to, so I guess is in addition to that acknowledgement of labor is more of a comment. Are you familiar with linker graphs from design protocol studies?
I am not, but yeah, I'd love to
So
hear about them.
you kind of
Mhm.
reinvented them, which is awesome to see
Okay.
with your chart of the connections between ideas over time.
Okay.
A linker graph, you take a sequence of design actions from
Mhm.
a protocol study of a design process
Mhm.
and connect backlinks and forelinks between
Mm.
ideas that have influenced each other,
Okay.
which allows for a really nice
It
visualization.
sounds like another
of the
good
process.
visualization of this process. I'd like
Because
to
you can see,
see
you know,
that.
periods of high broad ideation and then convergence. But there have also been some studies applying like quantitative measures to that, looking at sort of entropic measurements across the design process. And then you can use those to maybe assess different profiles or characteristics of sessions, which might
It
be
could
a
be
useful
helpful.
approach for this
Yeah.
kind of thing in the future.
Thank you very much. We'll look into that. Thank you.
Can I continue? Yeah, but link graphs, there is great book by Goldschmidt or Goldblatt or
Goldblatt,
about those.
okay.
Yeah. But anyway, so how long were the transcripts first of all, and did you consider using natural language processing for analyzing that?
I have thought of that many times at post this project. It's a natural thing to think about. It would be a good experiment to do with the existing data that we had. How long were the transcripts? They were, I don't know how to express them in terms. They were, because we constrained the ideation period to 3 minutes. It's approximately, I can only tell you in time about, and we could ignore the introductory part of the transcript where we introduced when the facilitator was introducing and things, maybe a minute of decision making on which 3 were the final ideas. I don't have the number of characters or the length, but I could show you some examples if you want to see.
But thank you and congratulations again.
Oh, thank you.
All right, this brings us to the end of the session. Let's give a big round of applause to all the speakers.
I wanted to remind the people that are presenting next session, please let's try it now and then we go eat, okay? It's better.
So everybody has to stay. Well, I'm kidding. Enjoy the break.
Thank you so much for your help. This was the best part of this tech setup I've ever been. Always in our camp, you made it like really reassuring. So thank you so much. I really-
My email? Not yet, not yet. Send me a link, right? Yes. Let's try it out.
day you visit
To unmute.
I think that's the problem in this area. Again, we face that problem in any kind of quality judgment. We face that no matter what the code or brainstorming ideas or whatever. So yeah, so we do that. It's a very good question. Like, does it produce, okay, the AI participated in some ideas, where did it produce better results? I can't say for certain. It's just that the people, it was more about how they felt about this.
Okay, so can I download it?
Thank you. Yes, we have more work to do. There's more we have published about some of the survey results. Not, I look forward to hopefully talking about it sometime.
No, but you don't need that. You can go directly to the download.
Okay, all right, even the next thing.
Right there.
Okay, where are you from?
Right, and so just.
I'm looking at academic group, but maybe it's just not. Cross-disciplinary work.
So we'll end. Is it?
Yeah. Oh, thanks. Yeah, well, I look forward to yours.
It's very fast.
It's working well.
That's not mine.
No, that's not, yeah, that's the Zoom. That's the Zoom. There you go.
Yep, okay, great.
So we have a backup plan just in case.
He says that computer is very slow.
Okay, if you want, we can do this one. So we'll just get, because I didn't get a charger, so we'll just make sure that I charge it during lunch time. So you want to go with the?
No, it works over there.
Do you have like videos or things
No.
to play? Okay, so maybe it
Should
should be
work on
okay.
that too.
Okay, let's see if then it works well.
Okay, let me take your, ask at work whether I can share that. And I'll. No, I don't think so. People's names, and we'd have to redact it because, so we should. We'll have to look at the transcript whether we anonymize it on the text or before we move it through another transformation. So I just have to look at that and ask. And I may have to ask permission of the participants to be told that we may have an agreement with the participants. We say that if we share this, so it just has to be anonymized. We told them their data would be anonymized if we use it in any publications or, so I just need to take a look at those details.
Thank you very much.
Of course, yeah, I can understand wanting to, I can see how that would be useful.
Yeah.
Actually. Yeah, I will do that.
I mean, as a technology person, I would appreciate, part of it, there's another way, whether it's like solidly understood, so communication, there's keys out, to make sure the answers you're getting. Are really good. Very difficult. So I'm sitting here trying to.
Yeah, that's the sound.
Is there another explanation?
We can increase the volume here, but it's coming from this speaker.
Yeah. So I'm just.
Yeah, I think I could.
One of the things I thought was,
No,
is that all you need is AI
this, right?
faster than another. If the humans wouldn't come up with.
Yeah, it's on the right one.
Yeah.
Right.
Then,
So try.
what it's doing is contributing to the cost, that's a little faster.
Yes,
Now let's try the Zoom and see if we can put it share this.
So they recorded sound. So we have to, there's a whole nother kind of body of things to talk about, like each fit into one 8-page paper. So, but yes, I think that.
Yeah. I mean, I work with AI a lot, there's trials and appropriation of code and moving that and sound.
Yes, we were on the code prior to this. Yeah.
Yeah. And so, I mean, I think, well. I mean, it's not, but I also.
Max.
Say something to.
Gotta go to the bathroom.
Right, we can't do that. Banging against the wall.
Are we testing all of them or?
Seeing when I, oh. that was-
Sorry?
Are we testing all of them?
We are testing all of them.
Thanks for sharing.
Yeah.
But the real question, so in those things, it's better for a human, better than a human.
Yeah, he went to the bathroom. So let's try the next one.
Me.
Yeah.
Right.
Yeah. Manage to log out from this computer. You go ahead. What do you need? This?
Yes, that one. No, yeah, that one.
But it's a good question. We were trying to record something for the data and all of the data, we were just trying to inform what you can see in the data. So we have a question of why, what might explain it is like.
Are you muted?
Well, the question
Yes,
from the
I
young
am.
lady on the other
Yeah.
side was along
Test, test.
do this. It's okay. Test.
No, I just hope everything works there.
Test. Test. So, okay. No Zoom for you.
Okay.
That's what we're sharing. Okay.
Okay.
So that's what we're sharing. We're not sharing just the screen.
Okay.
You can talk, you can, so the sound, it's all fine.
Okay.
Okay?
Okay. That's
It's
fine
not
for
the perfect conditions, but
Yeah, no.
I have no idea what's happening
No,
here.
no.
This is
You're
magic.
doing. You're doing.
Yesterday it worked pretty fine. Today it's not working. I don't know why. Okay. Try you. Okay. Yeah.
But he's been waiting.
Yeah, I just, I'm not sure if my call
Let me
works.
see. Is it?
Okay, double check, yeah.
I think.
Okay, so what do you need? I just to make sure that it works because it was something a bit funky before.
Okay.
Like the USB-C.
Yeah. I think that.
Do you have sound? Okay, are you on Zoom? Is it connected? Should be. You also present. Okay. You have sound on your presentation. No. Okay, great. So join the Zoom. Okay, so that we can share your screen. So we have the Zoom here. That's it. So the number, if you want, I can spell it to you. Yes. It's there. Working?
Private data.
Okay. Working? Oh. Is it PDF
Figma?
Figma?
So it'll work through the browser.
Sure. You wanted to share it. Maybe try it on this one. I don't know. You can tell me what's the. This computer is not super fast.
Which one is the password for the network?
So you join this network. I think the password is this one, Young University, and then you'll ask you for user. This is the user. And this is the password.
Yes.
Maybe it's better with my.
Sometimes just print them out so they have something for my hand just in case.
So this is the network. This is the password for the network.
Actually, I help you get them online.
Okay, do you have it? Do you want to short URL and what's the last part? E4, capital O, capital H, 8. Is that it?
Let's go.
Yeah,
Research
that was-
time.
I was
So the computer is not very fast, so I hope that this will work.
It really doesn't matter. It's
So what we
yeah.
do is we share the screen. We need, are you the first?
On second to last.
Okay, so what we'll do is we'll share this screen and we'll also need to shift for the PC. It will appear there, I hope.
Yeah, all right.
Okay, and then here we can close this. Right, and do your magic here. I don't know if you need to set this already.
Okay. So.
Yeah.
Okay, so I think.
Test. The clicker? Yeah. No clicker. Test, test. Test, test. Okay. You're done. Thank you. Thank you. Okay, so who's missing on the test? We're missing one person.
And it's on.
Are you presenting? Okay. Who's presenting? I need her
It's my turn now.
So now I need to share.
I'd like to be able to share the slides I keep presenter view here.
Yeah.
Can we make that happen?
Yeah.
So I have my notes next to the slides.
Do you have any sound?
No,
Perfect.
just visuals and.
So can I share my slide? Ah, okay. I
So
need,
you're on Zoom, right?
but someone else is sharing the slides and we
Yeah, so
cannot.
Yeah, yeah. No. I'll just stop.
Because it's the, where is the guy? Yeah, I've done it from the other side.
All right, so now when you. Where is the accent on your surname? And that's what I'm interested.
Just say,
And now.
just,
Now
you're gonna say my name?
So what do I need to do?
So, because I was gonna say my name, okay. So you can just say Josh and
Yes.
it's fine.
Yes, and
So then I don't say my name.
Yeah, yeah.
We already did it, so.
I would be
Working.
everyone
Yeah.
for the.
So when you come here, what we do is
For the
you connect,
people, it might
I'll
be
share your screen out.
like this one.
Oh my God.
Okay.
Well, you could not pronounce their name.
No, it's just the name.
Let's welcome the next person.
Yeah.
Okay.
All right, so now it's my turn to
Now
do the
it's
final
your
setup.
turn. Yeah, yeah.
So,
Remind me, it's HDMI.
yep,
Yes.
sweet, I'll close this.
So you have the sound, right?
Yes. All right, so now I go in here, I could share.
What's his name? Did he try it out with Figma?
Yeah, I got it, it's working.
Oh, okay. All right.
So now
So,
share my screen.
great.
No, I just. Yeah, and I was not in Zoom. I was not in Zoom. Sorry about that. Okay, so do you want
Share
to,
my screen.
let's try with
Sound. This one, because you want to check the slides, share.
try this. Try this.
Yeah.
Let's. That's what happened before.
This is.
Hello, we are missing one presenter for critical questions for sustainability research and computational creativity. Okay.
Okay, so now.
Yeah, yeah. Let's see.
Okay, welcome back everyone for this session on users and society. We have 7 papers, some long, some short, so it will be an interesting session before lunch. So our first speaker is Josh Andres. And yeah, I'll leave it to you.
Thank you. Hey, everyone. I hope you're having a good conference so far. Let me just minimize this. I'm presenting a collaboration between the Australian National University School of Cybernetics, technology music company Uncanny Valley in Sydney, and the Interactive Media Lab at the University of New South Wales in Sydney as well. The context around this work is to explore, let me do this here, okay. All right, the context around this work is to explore creative computational experiences in the office, looking at the cybernetic relationship between people, technology, nature, and machines. However, we want to expand this narrative beyond productivity in the office, which has been the focus of technology so far. To do so, we look at how technology has been conceptualized in the office. No slides. No, that's fine. Thank you, Rhoda. But that was on purpose. That's fine. In the early 1900s to 1950s, the dictaphones and ediphones were introduced to the office for oral dictation. These are the first machines that were introduced along with the printer, changing how we work and changing how machines occupy that space alongside humans. The 60s really seeded the idea of machines for productivity. For example, you see Gordon Pask with his self-adaptive keyboard instructor for enhanced perceptual motor skills. In the middle, you have Lick Leiter with his vision of human-computer symbiosis to look at the partnership between humans and machines. And the last one is Dorothy Vaughan. Her work helped us move from manual calculation to digital calculations, laying the foundations for office automation technologies. In the 70s, we see nature-inspired design or biophilic design. Plants, colors, and round shapes made their way to the office, changing how we relate to each other in that space. The larger picture shows the 80s and 90s. With the introduction of personal computing and the internet, we became more interconnected to work, but at the same time, we became more disconnected from the larger systemic picture. In the 21st century, advances in IoT and AI allow us to optimize processes. However, they also present challenges, such as the risk of excessive automation and potential sensory dullness. Efforts to explore sensory enrichment in the office illustrate the dynamic interplay between people in the office, the building, and their ecological footprint. That's the picture in the middle. The colorful picture shows the aggregated emotion. However, sensing emotion has become a sensitive topic with AI, surveillance, and the future of work. So looking at this history, what could we learn from this walk down memory lane? Well, today we are still spinning the same stories using a different technology, AI, to create office workers and AI partnerships for higher and higher productivity. This means that there is room to open up this narrative with the creative computational experiences we can create to move beyond productivity. The installation. We were guided by a core concept, creating a creative computing experience that enables office workers to experience multiple timescales in a way that is immersive, playful, and nature contemplative. In terms of the timescales, we drew inspiration from Stuart Brand's pace layer model, conceptualizing 6 timescales as relations between human activity, processes, technology, and nature. This range from changing in seconds to changing in decades or even centuries. In the middle of this screen, you see social media to nature. Social media was adapted in that model from fashion, and nature is at the bottom. They change from the fastest to the slowest, and they have an interdependent relationship. We contextualize the pace layer model to our office by assigning an API to each of the pace layers, which are detailed in the paper. As you can see, we have the real-time data, which is what I just referred to as having those APIs. Then we have ChatGPT-3, which we did at the time. And the data coming through is interpreted into a sentence based on its emotional properties. The sentences appear next to the labels and they move at a different speed to represent the changes in that data as well. Sometimes the sentences are insightful, sometimes they are witty, random, and that's okay. We wanted to explore these interpretations from the model. On the other side of this graph, you see library of sounds. This work contains 1,050 professional musical compositions that were created for this work, including nature sounds from the local surroundings. 80 people from across the university and outside the university labeled the sounds based on their emotional response. So you end up with the emotional response as interpreted by the model. We have those AI label generated, and then we have the labels as interpreted by the humans. We take these labels and we look for their semantic relation and we pair them up. These pairs become the seed for the generative music engine to generate the sound. On the top of the poster, you see the weather logo. So we use the weather API. Sunny weather makes the music more upbeat, cloudy, neutral, and rainy, melancholic. In terms of the materials and physical representations, we constructed a geodesic dome as an organic and nature-inspired shape. This created a dedicated space for contemplation, and it was also functional to help us perform the gestural interaction without losing focus. The semi-translucent dark fabric creates contrast, and also dimmed lit spaces can elicit moments of recollection and increase freedom from constraints, as reported in previous installations. In considering the role of interaction to amplify the concept, we drew on inspiration from movement and neuroscience studies, looking at the role of audiovisuals and motor movements to influence our perception of time. Slow sounds and slow movements can accelerate our perception of time. Think, for example, of Tai Chi. We had some issues with the sound, but I'm happy to share the sound with you later. In addition, nature sounds are known to have slowing effects on our physiology, and this can help people enter a state of contemplation. To articulate the interaction choices in this work, we lean on research on slow interaction. For example, we can observe temporal interconnectedness to represent the multiple time scales that allow the possibility for temporal interconnectedness to emerge through the contrast of the different time scales. We can also see temporal drift, where the device's ongoing representation of time departs from that of the user's daily cycle. For example, the time scales changing seconds to even decades, in contrast to the linear time of his life. And the last one is explicit slowness, where the user has restricted control over changing the device's pace. In our case, the user could not alter the pace of change in each of the time scales, and they could neither change the sound composition. Moving on to the user study and methodology. During the 6 months that the installation was deployed, we investigated a future form of creative computing experience in the office, using a research through design and a first-person explicitation approach. The installation is a speculative physical embodiment artifact that offers new knowledge about the design implications and potentials of creative computing in offices. For the user study, we recruited 18 volunteer office workers. They came from different institutions and did not receive any compensation for their participation. To implement the explicitation approach, our interview protocol included 3 episodes of technology encounters. These were composed as 8-minute solo exploration in the installation, followed by 8 minutes interview time. Alongside observational notes, images, and video recordings, and using an inductive thematic analysis, this resulted in 4 teams with 9 subthemes. I will share one of the themes next. In the theme reorientations to experiences of nature, participants shifted out of habituating the day-to-day workplace and into the realm of the natural world. For example, a participant said, "The audiovisuals rearrange you to the fact that you are in an ancient landscape." Another one noted, "You locate the building on country, as referred by the local indigenous to the land, the intertwined connections and beliefs, in a way that is not often in your mind." Comments like this suggest an expansive conceptualization of the office as part of a greater set of stories, trajectories, and relations. Participants then described emerging worlds. "I am hearing insects and water sounds. It feels metaphoric, all the different dynamics coming in." Another one said, "It is like the God trick. I can see everything, but I am nowhere," referring to an alternative view to that of their office-bound self, as enabled by their dialogue with the installation. Okay, implications for creative computing experiences in offices. There are 4 main takeaways in the paper. I invite you to have a look. I will share one next. Ephemeral qualities in creating computing experiences using generative AI. Our work explores generative AI for creative computing experiences in the office. We process real-time data to create outputs that resulted in ephemeral experiences. These transient audiovisual experiences make each engagement episode distinct, enhancing the appreciation of time and reflecting the constant flux of nature. Participants reported gaining a higher level perspective, revealing relationships and temporal scales beyond their office life. This suggests that our installation highlighted a broader web of relations through its dynamic audiovisual composition. In the tradition of material performance, our installation destabilizes the boundaries between the human and non-human performances, offering office workers a reflective conversation through their interactions. In practice, we embrace the inherent unpredictability and variability of the data streams. While we curated the physical installation and interface representation, such as the fonts, motions, interactions, and some of the initial audio attributes, we did not control the content itself. This allowed the generative AI to act as a performative material, resulting in an ephemeral audiovisual composition that invites curiosity and contemplation. To conclude, our goal was to prototype and study creative computing in the office, delving into the human, technology, and environment relations to better understand what it might offer to office workers beyond the structured rhythms of office life. This work contributes to designing technologies that promote engagement with temporal diversity, enhance ecological awareness, and expand human-machine narratives beyond productivity in the office. With that, I'm happy to take any questions. Thank you.
Thank you very much, Josh. Fascinating job. Any questions from the audience? No, maybe, well, yeah, right, we have one.
Thanks for the talk. Oh, sorry. Thank you for the talk. It was really interesting. And I mean, it was it looks really, really cool what you did. The question is mostly regarding, so do you think that this will, I mean, let's say from an employer's perspective, do you think that this may increase the productivity in the office, or do you think that the atmosphere in the office will be better by using systems, this kind of installations or creative computing installations? Like I'm thinking about so there are some benefits that you just mentioned now, like that that people may have. But do you think about the atmosphere and the productivity? What do you think about what's going to happen?
Oh, sorry, we just have one, so we need to share it.
So that's a great question. And I like what you did there, because I mentioned that we can expand the narrative beyond productivity in the office, but you actually switch that around to go back to productivity. So even we have this narrative of technology for productivity, for higher partnerships between humans and machines. However, when we think about how we have structured our rhythms of work, we can actually change some of that by having some of these experiences. And some of the reasons to have these experiences could be if it brings a little bit of joy to someone in the office, that is already a valid reason. But if it actually creates opportunities for expansive thinking that depart from the structured rhythms of work and attunes you to some of the rhythms of nature and the larger systemic picture, that would be one of the reasons to use it, especially depending on the type of work. So if you are working on policy, if you're working on technology, you want to think about technology not only as a transaction, but a set of relations, asking questions such as what would happen if this technology goes mainstream, for example. So by creating these experiences, you have that top of mind to really be more critical about the type of work you do. Yeah, thank you.
I couldn't see which one was first, but yeah.
Thanks for your great talk. I'm quite curious about the this the as the title suggests, like a temporal diversity and a connection to nature. Both of are super duper important for office workers, I'm sure. And I'm also aware that the traditional office furniture build makers like a Steelcase and the Kokuyo, those furniture designers also thought about those features, I believe. And one question is what is some kind of shared features of those furniture? Like, have you found some interesting facts? And the second question is like, have you considered to compare your approach to those traditional method or furniture, let's say?
Thank you for the question. So let me just rephrase a little bit to see if I understood correctly. So you were commenting on how the furniture designers for the office, for example, take an organic approach and use organic materials. And that is known from biophilic design from the 70s to making its return in the early 2000s to have actually opportunities for well-being, to help people feel a bit more calm. And this room is actually an excellent example because you can see wood and organic materials everywhere. So how do I think about comparing that furniture to our approach? So, okay, so then many of the design choices in the prototype were aligned to this idea of amplifying the concept of experiencing different temporal timescales and connection to nature. One example is the geodesic dome. So the geodesic dome by Buckminster Fuller, when he was looking at the microscope, he found this structure and then it became something that was used throughout the world in many things. So for example, I'm just going off tangent, but I like this, which is when he looked through the microscope, he found this pattern, and this pattern was actually used to create the first soccer balls because you can see that pentagon. So if we can amplify the concept by taking on these additional approaches to really amplify that organic connection, I wouldn't necessarily compare it, but think about how to enrich it. So, yeah, good. Thank you. Yeah. Do you want the last question or no time?
Yeah, unfortunately, I think we are up with time, but yeah, do grab Josh during lunchtime for more questions. So thanks, Josh, again. Please join me in thanking. Next is Maria Teresa. We're just setting up now. Right. So Maria will talk about some design considerations for musical landscapes, so we'll need to have some sound. Yes, it's working. So, please, Maria Teresa.
Yeah, thank you. Hi, everyone. I'm Teresa. I'm here presenting the work on behalf of my co-authors, Stephen Kroll, who is the lead author of the paper, Matthew Butler, and Kagatai Gonku. So, experiencing visual art is a privilege that we as humans can enjoy. But there is a small population of the world that is not able to actually fully enjoy visual artworks. Because they have different levels of visual impairment or because they are blind. So museums and art galleries have adopted some mediums to be able to increase the accessibility of visual artworks. Like the more commons are audio guides and guided tours. However, these mediums are very much descriptive, focus on the descriptions, and they have shown to not really add much to the aesthetic enjoyment for people who are blind or have low vision, which I will be referred now as VLB. Recently, some research has been done in using tactile methods as another alternative for people to actually independently access low-level features of artworks. And that has been very successful as well, because people are not depending on others to be able to describe to them the visual artworks. However, these methods also lack a bit of, they're limited on the descriptions that they have, other kind of level of descriptions, like color, for instance. And tactile representations of our works are also very scarce. So it's very difficult for museums or art galleries to have tactile representations of all their artworks. So with this work, our motivation was to explore another modality that has recently been studied and that has shown potential to increase the accessibility of our works, which is the use of soundscapes. And we wanted to explore the use of automated soundscapes, not only to provide information about the artworks, but also to increase the aesthetic experience of visual art for VLB people. And with this work, we were looking into understanding and hopefully identifying some design considerations for the future development of automated soundscape systems for visual art. So with this aim, we built a prototype system with the idea of identifying, so the system would be able to identify the perceived emotion of a painting, of a visual artwork, and do some object detection in order to add sound effects. So the emotion classification was done in order to understand kind of the mood of the painting and be able to produce a music score that had that kind of emotive tone on it. And object detection was used to basically try to identify the objects and produce some sound effects and add them to the soundscapes. So this is an example for the painting that is shown there. So this is one of the soundscapes that was automatically generated by the system for the painting, which I'm purposefully obfuscating here for everyone. So having this, we wanted to do an in-depth qualitative study with people that were blind or have low vision. We have 5 low vision participants with different conditions of low vision, basically at different levels, extents of vision. And we have 5 blind participants. Most of them were blind since birth, but there was one participant that was able to perceive light and darkness, but present themselves as blind. What we did was we conducted 1-hour interviews on Zoom, mainly because it was difficult. There were some mobile difficulties to get people, to a place where we wanted to have like an exhibition of the artworks and have like tried to replicate that experience, but it was difficult to get to do this. So we decided to go for our next best alternative, that was Zoom interviews. In these interviews, people were able to experience the artworks together with the soundscapes in order to understand very well how the soundscape would work with other accessibility methods. Sometimes we gave a description of the painting first, of the artwork first, and then play the soundscape. And in other times we play the soundscape first and then gave the description. So the first thing that we found by all the participants was that they all confirmed that the soundscapes help them build a connection. So for instance, one of the participants says, there is something about music that it sets the mood very, very quickly within those few seconds. So this is confirming something that had already been shown before, that the soundscapes really add a different dimension to this aesthetic experience for people with vision impairment. But other findings that we found that it was really, really cool was that some of the participants said that the soundscapes created focal points. So basically, they weren't able to perceive some of the objects or the subjects that were in the paintings, but with the soundscapes, they were made aware of them. So for instance, one of the participants says, it's like the dog is saying, I'm lower to the ground, but I'm still here, because basically they hadn't perceived the dog. They also, the participants, one nice finding was that they really liked the soundscapes that kind of created an atmosphere of a sequence of events, kind of told a story. So one of the participants says, for instance, in this one, the hit of the ball and then the ball landing and stuff, it is certainly conjured up an idea of a game of tennis. So basically, the soundscapes providing kind of a narrative and a story that goes with the painting. That was something that they found really interesting, and they really helped with that connection. So another thing that they suggested that was really good was that they could see when the soundscapes provided this contextual information about the painting. So this is more about giving them information not only about the subjects or the objects that were there, but more about things like the period of time or the place where the painting was set. That was really good. Like for instance, this participant said kind of like folk music, which you would expect sort of something that is a bit more, something that's Dutch. That's really lovely. So that really enhanced that experience for them as well. Something very interesting that we found as well was that, because they have different types of conditions, the diversity of visual acuity was also an important aspect that has to be taken into account. In terms of the extent of the vision and the onset of vision loss. So for instance, this participant said, I had full vision until I was 25 because I know what things look like. I know what Wimbledon looks like. That music initially is going to take me to something I have previously seen. So she was remembering this time when she used to go with her father to Wimbledon, and it was really obviously made her felt that connection with it because it broke those memories in mind, those images that she had in mind. But it's different, obviously, for other people that haven't been able to, perceive this or have those experiences because they, for instance, were blind from birth. And obviously, as in any experiences with art or anything, there were the effects of suggestive taste. Some people really like the ones that have animals on it because they like animals, so they were very happy with it. Some other ones were like not so happy with that. So obviously that also play a role in how they perceive the soundscapes to act on that. But obviously, I mean, this was a prototype system. It was very simple, and what we wanted to understand, it was, what is it that people that is blind and have low vision would need or want in this kind of system. So there were inaccuracies, many of them. So one of the things that they pointed out is inaccuracy of sound effects. So for instance, in this one, they said they sound as though they are in a room that doesn't sort of say it outside to me because the painting is actually set outside. Thank you very much. And they said also, for instance, in this one as well, I didn't realize there was a, I don't know if you realize there is a sound of an umbrella opening or closing, something like that. So I hadn't realized it either. So they said that that umbrella sounds very contemporary instead of sounding from the time period. So that's also the inaccuracy that they were talking about. Then they were also talking about the inaccuracy of the music in terms of the mood or of the painting. So for instance, in this one of the participants says, it is not quite what I expected, especially if it is a racehorse. It is a bit slow and a little bit, not somber, but a bit serious. So they didn't really think that, being the subject, a racehorse was really going the music with that. So that's something that we need to think about. There were also many comments. We were very lucky to have actually a sound technician within the participants, and actually a lot of the participants have a lot of experience with music. They have played music instruments, so they were knowledgeable on music, at least more than me. So they pointed out things like the timing of the sound effects. So for instance, this participant said, when we are listening and we are getting all that information in, we need to process it. If you give us too much information at once, it answers all the questions at once. So it is very important to understand when to introduce the sound effects so that it's not overwhelming for them and that it gives them time, because that's kind of the process that we go through when we are experiencing visual art. We discover things, slowly, not everything at once. The volume of sound effects as well. So some of them were too loud for them. The sound effect spanning, which is very nice. That was a very nice thing, because they were saying this is related a bit with the idea of creating focal points. So the sound effect spanning would tell them, kind of in which location of the painting things are. And diversity of sound effects as well. So we have a small database of sounds. So some of them were reused for some of the experiences. So some of the participants like it because they thought that it would allow them to really recognize again what they were listening, but some of the other participants said that that didn't create a unique experience which should be created. So that's something that has to be taken into account. And also the balance of methods. So in terms of the order and then they are introduced. So as I said before, we gave them either the description first and then the sound escapes, or vice versa. So some of the participants said, if you got nothing but a piece of music, I'm gonna make my own piece of artwork. And they didn't like that. So they wanted to have the description first. But then some of the other participants said, audio descriptions can often give away the punchline. It gives away the whole thing and you don't get to be part of the mystery. Part of the enjoyment of art is identifying the work. So again, there were these mixed views about, first description or second or what is it? So it's something of a preference, obviously, yeah. And also the length. So some of them were saying that the soundscapes were too short, or the descriptions were too short, or they wanted them actually longer. So there are also preferences there. So after this, there were many things in the paper, but we found these design considerations, which basically, as I said before, the idea was we wanted to understand design considerations that help with the aesthetic experience. So the first one is enhanced comprehension through narrative elements. So telling a story, basically that's something that really enhances the enjoyment of the music. There is obviously a problem there of what the artist wanted to portray, and then the narrative that is being given. So that's something that has to be taken into account. Employ historical and contextually diverse sound effects and music to ensure a representative experience. That's what I was saying with the sound of the umbrella. So being contemporary from the time. Include ambient sound effects to aim for more immersive experience. Provide controls to customize soundscapes because of the different preferences from the different people. employ methods of audio reproduction for sound effects, because this really, as I said, it gives information about location, for instance, where the things are located. And obviously, this is a no-brainer combined with other accessibility methods. So the more modalities that there are for them to explore, they like it the best. So I just wanted to close with this. These were some of the comments that they said. They were very happy, really enthusiastic with the work, and I see that there is a lot of potential from the community, from work that is being done in the community to hopefully help with this. I just wanted to encourage everyone to do it. Yeah, I want to say it's a boatload of fun. I appreciate what you're doing, and I hope you're paying more. So yeah, please give me money. And I want to finish with the experience that was the least favorite, but most memorable. Thank you.
Teresa, that's great work. So any questions? On here.
Thanks. Great work. Thank you. There's obviously so much debate at the moment about AI replacing jobs for musicians. And whilst looking at this talk, I sort of perceive that you're doing some work that might highlight an area through AI that could then result in the job being given back to musicians, in the sense that, like, a well-funded gallery with a couple of thousand artworks could quite easily, well, I say easily, but you know what I mean, like there could be the budget, say, if the realization is being made that this is an effective form of communication, that a sound designer or a composer would be given that work. Or I'm sure there are many examples of that already being done, but I just wondered about that perspective.
Yeah, so actually, one of the motivation is because there was some research that was done that they did some workshops with musicians, human musicians creating the soundscapes. And that was very well received. The problem is that obviously that's costly in terms of resources, time and money as well. So that is very difficult to scale that. It would be much better. I mean, there is no doubt of that. The soundscapes will be a lot better. It's just about question of scalability, I guess, depending on how many artworks. But yeah, it would be really great if it can be given back to the musicians. Yeah, I agree with that. Yeah.
Thank you. It's really interesting work and a really interesting idea. For me, there's a problem here, which is that there are two very distinct modalities of communication. One is the sounds, which are incredibly directly semantic, right? We don't say that's the sound of a dog, we say that's a dog. We do that translation directly. The music, on the other hand, is not semantic at all. It's semiotic, and the semiotics are different for every single listener, which means that it seems that you're kind of pulling in two different directions at once, and that's not terribly helpful, especially using that particular generative system, which is really quite limited, and piano sounds all the time, and so on. So there is an enormous research field out there in music of soundscape composition, which relies on using natural sounds in a musical way. I wondered if you'd considered looking at this at all?
I wish Stephen was here to answer that. So sorry. We really look into having different, which sort of sounds we could use. And we ended up using this small database of sounds, which probably, they're not natural. But actually, the participants were pointing us towards some databases of sounds that they thought were much better fitted for these purposes. So possibly, definitely that's something that could be done in future work. And as I said, I mean, this was a prototype system was done. So it was more like a test of the concept, but definitely even the participants mentioned other sources that would be better as well. Yeah.
Thanks, Teresa. Yeah, so please join me and the participant in asking for more funding, and And in thanking Teresa. Thanks again. Next, we have Anna-Kaisa Kaila on gardening frictions in creative AI.
Great, thank you. Yes, so I'm Anna. I'm from KTH, Royal Institute of Technology in Stockholm, Sweden. And I'm going to be talking about today about our research on emerging art practices with AI and what kind of frictions and design implications they come with. So as we all know already, there's this emerging community of practicing artists who are exploring different kinds of AI-based tools and growing and cultivating a range of creative expressions that they can provide for artistic work. One visual artist that we talked with described their process as something akin to gardening. Quote, "It's like if I was growing images in a garden, sowing the seeds and then nurturing and breeding them," unquote. We wanted to learn more about how this practical, messy, everyday reality looks like for artists who are engaging with AI in their work, and how the material and conceptual sensibilities of these artists have changed as a result of them adopting AI in their work processes, if at all. In specific, we wanted to look at what kind of frictions artists have encountered in this process. And now, back in the day in high school physics class, friction was defined as a contact force that resists an object's motion on a surface. So it's something that is required for an object to be able to move forward and not slip back and forth. But in this work, I use the concept of friction in a slightly different way. And it is used in a meaning that it is typically referred to in critical algorithm studies. And in that context, friction refers to the study of tensions and contradictions involved in the processes of datafication. So in the framing of AI and art specifically, friction happens at the interactions between the sticky materiality of art making on one hand, and the AI tools on the other hand, which are not just technical objects and software processes, but come with heavy packages of culture and politics and competing narratives embedded in them. So friction occurs when something cuts the normal flow of creation or creative work in a way that calls the user's attention to something that doesn't seem quite right. And it is in those exact moments that we wanted to zoom in. The data for this study comes from a series of interviews, 18 in total, that we conducted in 2022 to 2023 with total 20 artists who engaged with AI in their work and who reside in Nordic countries or have some strong connections to them. So Finland, Sweden, Denmark, Norway, basically. They were between late 20s to mid 60s of age, and 6 of them were women, 14 men. These artists come from different domains of art, and they did not necessarily identify themselves as AI artists specifically, nor did they necessarily call their work or their the domain that they're working in as AI art, as you can see by the various diverse labels that they provided for their work. But AI was nevertheless the common denominator within this group of participants. And that was sort of what tied this group together. So therefore, we are referring them as AI artists, giving a shorthand for this community. And we asked them about how working with AI had changed their practices and creative processes, and whether they had encountered or overcome any specific technical, practical, or creative challenges. And these results were then analyzed using reflexive thematic analysis. In other, I think I jumped over a slide. I did, yes. So we identified 3 layers of frictions. There were material frictions, social and procedural frictions, and frictions found in role reconfigurations. So in other words, we saw frictions firstly against the elements of artists' immediate surroundings, the environment in which they conducted their work in. And secondly, facing the wider circle of social encounters around them. And thirdly, as introspections of artists looking back at themselves their artistic identities, and the core definitions of what they regard as an artwork in this context. So let's take a closer look at each of them. Frictions in material interactions emerged with issues around hardware and computational resources, software and algorithms, and data. For instance, some artists had no access to sufficiently powerful institutional computing resources to run the models they would have otherwise chosen. And the model outdating was a risk that some of the artists learned the hard way to be wary of. Finding enough data that was of sufficiently good quality, preparing it for a suitable format for the model they chose, and making sure that it didn't introduce any unwanted and unwarranted linguistically or culturally outdated expressions into the dataset was a lot of work, and it was complicated for many of the artists. But what was interesting, we found these frictions to be fundamentally inseparable from the artist's personal experience and the resources, as one might expect from a socio-technical system as creative AI, or as philosopher Karen Barrett would formulate it, entanglement of the human and the machine. The quotes here on the slide from participant 14 illustrates this perspective. The participant said, "I'm not that literate in the sort of computer parts behind it. So I mean, the training of the models runs on the Colab and generally it just works or it doesn't work at all. And there isn't that much space for my part to actually tweak and configure it." So this illustrates that the technical elements of the process are just one side of the coin. And the other side is the capacity of the artist to seize these opportunities. So one could say that the affordances of the tool are only really there if the artist can afford them. Secondly, we found limitations of financial and time resources, collaborative challenges, and frictions of modality in navigating between divergent means of expression and control, text, image, visual domains. For example, the financial cost of cloud computing affected the planning and implementation of some artistic work processes. Participant 5 said, from the technical implementation, it's a longer process, and to predict the outcomes of different iterations is harder because the iterations take so long to be processed. This often meant that the artists were dependent on collaborations with institutions or corporate partners. Participant 13 noted this. It's normally institutional access because I can't buy my own. It's like thousands of euros. It's expensive artwork. But social frictions also occurred in staffing changes, rigid management practices, shifting deadlines, or simply in exhibition planning schedules that were in the range of several years, which was just unpractical for a kind of quickly changing domain as AI is. I think I'm going to skip the next one here. Thirdly, we saw frictions lead to introspection and renegotiation of artistic identity, agency, and authorship. These changes led the artists to reframe their self-assigned work descriptions. So they called themselves curators or producers, or as in the beginning, they described their work as gardening or archiving. Participant 17 described this in more detail, saying, quote, "I think working with AI forces you into putting yourself in your place, like you have to reduce your ego. This relocating of control and having to accept surprises and to work against the resistance and grit of the model was one of the elements that some artists specifically sought for in AI tools. But also, friction led to redefinitions of the core ontologies of what is an artwork and where does it end, and does it have to end? Does there need to be a closure for the work to exist as a work? Or what are the limits of where an artist can claim ownership or demand attribution for various outcomes of this process? Participant 3 phrased this as, quote, "I think it has broadened my horizon in regards to how to think about art and artwork. When are you inspired by something, and when is something a part of your work?" These individual experiences expose some structural vulnerabilities in art making and how the asymmetries of access lead to widely different realities of how AI tools can serve or fail to serve the users artistically. Artists that had strong technical, financial, and institutional support could afford to explore and experiment with AI tools more freely than those colleagues that were more resource poor, where they had to make these calculations of whether another iteration would be worth it or not if it was too costly for them in terms of time, but also in terms of money. And these frictions also tend to accumulate. And in extreme cases, they would lead the participant or the artist to reconsider whether they really want to and can afford to continue working with AI tools at all. Secondly, frictional encounters with institutions and different commercial gatekeepers illustrated how entanglements of power and privilege determine the nature of interactions that artists can have with AI technologies on many levels, from the individual all the way to the social. And finally, the frictional ambivalence and unpredictability played a constructive role in many of artists' interactions with AI tools, such that what seemed like at first like a restriction proved to be a seed for something new and valuable. So if the development of AI tools for creativity, or really tools for any creative work, aims at widening or democratizing access to creative endeavors for wider user populations, we should pay close attention to the practical material realities of what artists face when they adopt these tools and use them. So based on our observations from these interviews, we propose 3 inspirations, so suggestions for how creative AI tools or applications could be designed with and for frictions. Rather than a comprehensive list of recommendations, these 3 aspects are intended as inspirations for further analysis and reflection. The first suggestion is all about how the AI tools are culturally embedded and how we should resist viewing the user and the technology as separate and independent entities. The friction emerges neither in the tool or in the user, but in the amalgam of them both, the interconnections and encounters between them. And these kinds of really valuable perspectives get lost if we develop and evaluate creative tools in isolation from the messy real-life contexts where they are being used. The second suggestion reminds us to be careful to not lump users together in 2 rough categories, because that obscures how their particular socioeconomic contexts and realities and varying levels of technical expertise play a big role in how accessible affordances of the tools are. And this would include embracing the user's own understanding and their own language of how they talk about AI tools, and accepting the fact that sometimes the artist may use vernacular expressions and explain things that are formally, technically wrong and misunderstand processes. But if we take these descriptions that from a technical point of view are just wrong, if you still accept them as an alternative readings of the tools, they provide some insights into how those tools could perhaps be designed in ways that would be more widely accessible and more widely intuitive for different kinds of user groups. And the third point is calling off for openness and sensitivity to the ambivalence between distressing and enriching frictions. And this resonates obviously with Donna Haraway's call to stay with the trouble. So now we have stay with the friction. The idea is to approach the artist's experiences of frustration and friction with curiosity and openness, and to resist the urge to rush into fixing these frictions as if they were bugs that need to be getting rid of. So the study of friction starts with the individual and the relations that they form with their surroundings. But zooming in on friction specifically exposes also entanglements of power and privilege in the social and commercial infrastructures of art-making processes. When these effects are not exclusively, while these effects are not exclusively applicable to AI art, obviously, they seem to be more pronounced in this particular domain, and especially with computing-heavy data-driven systems. So for these reasons, our 3 suggestions invite the development of creative AI and computational creativity tools to approach frictions not as a weed to be removed and poisoned and prevented, but as a creative resource in itself worthy of care and nurture. Thank you.
Thank you very much. Any questions? Yes.
Anna, thank you so much. This was super interesting. There are just so many different interesting things in there. I have a couple of related questions. I was really intrigued by this idea that artists shared that these tools, these AI tools, are threatening to their ego. I feel like there is just so much there. So I was wondering if you could please elaborate on how, like, what exactly is hurting their ego in this process? And more broadly, I wonder if this could also explain more broadly resistance to AI from the arts community.
Thank you. That's a great question, and it's really an interesting tension. It keeps I keep seeing it in different contexts. This sort of push and pull between the motivation of artists to use AI specifically for the randomness, for the ambiguity, for the surprises, for the unexpectedness, and at the same time, sort of losing themselves in the process of knowing that if this process gets to be the creative part of it, what's my role? How am I needed here? Or if we find this as some of the artists call themselves curators, that I'm going to this space and I curate, I select and pick and choose the best parts. Am I still the artist? Because curator used to be a very different role in the artistic infrastructure. Have I given that role that I used to have, that I used to cherish, to someone else to become a person that I did not want to be in this pipeline? Or maybe is that opening something new for me? And it's a very conflicting view of the process and the roles that are available. In part, it's about introspection of how the artists define themselves. What do they call? Where do they accept their role as being redefined? But it's also a social construct of how the work is being viewed and reviewed and critiqued, and whether there are some aspects where the artists will expose themselves for criticism by allowing the process be open-ended in ways that is no longer so clearly like cannot be traced so clearly back to their own ego. So it's I don't think there's a clear either or answer to that, but it's a very interesting field.
Hi, thank you for the great presentation. In a study about designers, the ownership of the felt ownership of the work that the designers have done kind of shifted more towards them when they elaborated with their work with the AI tool. So did you witness that kind of development? At first, the initial outcome felt to the artists more like AI generated or not theirs, but then they kind of built the ownership throughout their work, or was there that kind of finding?
Thank you. Yes, absolutely. That happened. It was an aspect that we discussed on the workshop on Monday, quite in some depth, about this concept of how effort is part of how ownership and authorship is being built into the work. That when you go through a lot of processes, you make a lot of effort and sweat, and then it becomes yours. I wonder if there's a little bit of difference there, though, if you're designing for someone, for a project, in contrast to being an artist, where it is about you and your expression and your artistic identity, where it's maybe the vulnerability to that particular aspect becomes a little bit different. But yes, there was absolutely that sort of process going on.
Thank you so much. Thanks again. So please join me in thanking our speaker. Wonderful. So we move on with Piotr Mirowski, who is going to talk about improbotics, I guess. So some more improvisation. So great.
Hello, good morning, everyone, and thank you so much for the invitation to present this talk. I'm so delighted. So I do have a day job at Google DeepMind as a staff research scientist working on AI, but I'm also a theater director in my spare time, which I have a lot, I guess, with a company called Improbotics, and of course that involves AI, as you can expect. So in my day job, I'm interested in participatory AI, engaging just like we. So right now, artists and society around AI as a creative tool, a co-creation tool. And I just wanted to pitch two papers I published recently. One was specifically at CHI on storytelling. We built a system called Dramatron, which was generating interactively screenplays. That study was done 2 years ago before ChatGPT hit the fan, and everything changed after that. And then more recently, we interviewed in Edinburgh 20 comedians about the use of AI. And a very good quote was, "It writes cruise ship comedy from the 50s, a bit less racist." And of course, they discussed a lot about all the issues of hegemonic reinforcement of stereotypes and censorship that comes with this. But improvisation. Improv is about, it's just like a language model. It's about making things up. It's theater without a script. It's about spontaneity, being in the moment, communication and collaboration, working with your stage partner, making them look good. It's real-time dynamic problem solving, according to Brian McGurko. And I've been trying to improvise with robots and chatbots since 2016, just like this gentleman over there, Corey Mathewson, who is also a co-author on this paper. And then we met, we started working together, collaborating despite distances. There was an ocean between us. I'm based in London. And we did lots of shows, created a theater company called, oops, I'm going this, play. No, play, called Improbotics. So Improbotics is a company where we replace the robot with a human actor getting lines from the AI via an earpiece. So now they are given the text. They don't have to think about what they're going to say. They don't have to be in their head. They can be in the moment with the stage partner because the text comes to them from AI and they have to deliver it with physicality, emotional expression, and timing. And it's what's going on here. Now I'm switching. So we did lots of shows, like hundreds and hundreds of shows over the past years. But last year we were in Edinburgh. That's a poster of our performances. We were every night at 6 p.m. at the Gilded Balloon, performing with robots and chatbots and a whole wonderful cast of human improvisers. So the Edinburgh Festival Fringe is the largest festival of live performances in the world, in the English language. Over 2.5 million tickets sold, and we were competing against 3,600 other shows. So we had to sell our comedy show. And 60,000 performances, drawing a huge crowd of tourists. So our show had 26 representations every night at 6 p.m. for 1 month. With 21 cast members, we rotated over time. We sold close to 1,800 tickets, which is about 70 audience members per night. We did sell out a few times, which we're very proud of. In a 100-seat venue. That's how a venue looks like. So it was at the Gilded Balloon, which is basically like a student building, converted, like everything in Edinburgh, like every church, every school, every gas station becomes a venue during a fringe. So here there were like 8 venues at the Gilded Balloon, and we had this wonderful 100-seat space. And oh, most important, that's Boyd Branch. He is the lead author on this paper. And he's a faculty at Coventry University, and of course, founding members of Robotics. And yes, and this is the night before the tech. We still look happy. Gosh. So why am I presenting this at a scientific conference? Well, because we actually wrote a paper about this one, which you can read. And we were asking effectively 2 sorts of questions. The first one is the advances in dialogue systems in the context of multi-party chat on stage. And the second one was about the participatory design of AI for performance and the audience perception in a very changing context. So let's start, first of all, with designing a system for simultaneous interaction with multiple people, multiple actors on the stage interacting with AI. This is our setup. The bulk of our show was consisting in this setup. So we had a microphone, a USB microphone on stage that was picking up the sound, mostly from the stage, and sent to speech recognition. So speech recognition lines appear in green on the projector screen. And every time there is a line from speech recognition, it's fed into the language model that just keeps generating continuously. A continuous stream of generation from language model based on whatever prompt comes in. So all those lines in white are language model generated lines. Then there is a curator, because of course we need to pick the right line, the one that's least offensive and maybe the most relevant to the show. So that role is a human in the loop. Here Paul is holding a tablet and which has the same set of lines, and he's just picking the lines that are relevant for the show. And then those lines are delivered by the actor, Jody, wearing a headpiece, a headphone, and a radio, an FM radio. Perfect analogy that works very well in a theater stage. No Bluetooth, never Bluetooth. Never, never Bluetooth. Thanks. Okay, so you know. Okay, so that's it. That's basically that's how the show works. And of course, well, the last thing, they are the other humans. Because it's an improv comedy show, we are just doing improvised theater. So it has to be like a normal live performance. That's what the operator sees. So the operator, typically me, on a laptop is prompting. So there is speech recognition that goes into the system, but I can also just type in the red box extra lines of dialogue if it didn't pick up. Or in the blue box, I can type extra prompts like the context or the relationship between people or maybe some stage directions, which all go into the prompt construction system that feeds into the language model. I can also change the names of the characters, which is very important. So here we see all the lines generated by AI. This one is speech recognition. And here you see twice the same line. You're saying my toenail clipping habit is causing the issues in our relationship. Well, this is generated by AI. It was picked, and so then that's why it appears second time. The curator, holding a tablet, is seeing kind of the same system, but much simplified because it's only about clicking and picking lines. She also has more buttons to, let's say, be more punny or be more snarky, like extra prompting systems. So, does it work? I would like everyone to take a deep breath and lower your expectations. Okay, so, well, it works all the time. Latency. Timing, that's the most important thing in a live show. So forget about your AI systems that take 5 seconds to respond. This has to happen in a fraction of a second. So we need a high-speed internet connection in order to be able to access data centers of OpenAI, Microsoft, or Google, running various language models, or even better, we run it on the laptop. That's why I bought an M2 MacBook with 96 gigabytes of RAM to run Llama 2 locally. Don't trust the internet. And then, of course, you have to control the robot via Wi-Fi. There's a tablet, a projector. We have 20 minutes get in. No, 5 minutes, because we need to get set up the tech, and then we need time to warm up, because that's the most important part of the show. And then we need the audience to get in. 5 minutes. And we need a backup plan for everything. So the tech, well, lots of software, Touch Designer, Whisper, Llama, Stable Diffusion, because we also do improv with images, local speech to text, text to speech, and FM radios. How does the dialogue, multi-party chat dialogue work in that situation? So I'm chatting as the host, introducing the game, meet the parents. So I got the suggestion, soup. What are the condiments and ingredients of the soup? Ketchup. Okay, ketchup. That's great. So Alex is brought by something who is the son of Julie. Let's see where it goes. So I just said that. The language model the speech recognition picked it up. And so the language model starts generating lines already. And Paul walks in and starts speaking. You're gonna love my mom. She's such a cook. It's very unique in her cooking and quite simple in her cooking, but you will love her like I love you. More lines generated by the language model. And at this point, the operator picks one line, but far back in the history, it's warming, comforting, and perfect for a cozy night in. Okay. And then they continue the conversation. Yes, it is. The mom, Julie, says, Alex, I'm delighted to meet you. She's very formal. The language model keeps generating. And then the operator picks another line, which is again back in the history. It's not the direct response. Unique flavors and dishes always make for a memorable meal. And Julie, oh, that's what I always say. And we've got as unique as possible. Can you do a special? Absolutely. And new line, I can already tell where Paul gets his hospitality from. What did we just see? Oh my God, 5 minutes. Okay, so basically, dialogue is, we have this idea of dialogue as SMS messages. No, that doesn't work this way. It's like a interplay, stream of text that sometimes intersects. That's how dialogue works. We can chat about it. Okay, so participatory design. Well, our biggest worry was that because we used to work with GPT-2, GPT-3, or even a language model I trained myself 7 years ago, we were worried that instruction-tuned language model would be boring. But at the same time, we had to face the fact that the audience now had used ChatGPT, so they had higher expectations. How do we resolve that trade-off? And then we workshopped together games where the AI can complement the actors. The AI would not be the object of a scene, but just a participant with all the actors building something together. And also we workshopped over kind of games with AI as idea generation. So we had, for instance, improvised TED Talks with slides generated by AI, or a movie pitch with image generation. So during our performances, before and after the show, we had a QR code and a little spiel for the audience to ask them to, well, consent to give us some data for an academic paper. And they did, because we wanted to use the theater as a laboratory to study actors and audiences responding to real-time AI. So these are the responses. What drew you to the show? I'm curious about robots AI. I love improv comedy. Okay. Before watching the show, what were your feelings about robots AI? Curious, love them, excited. Okay. During the show, I found myself mostly watching improvisers work around limitations of robots, laughing with the human improvisers, laughing at the human improvisers. Human comes first. These are the top responses. What I liked most about the show was watching the improvisers try to make sense of strange and funny ideas generated by the robot, followed by watching the robot and humans create funny, entertaining stories together. Much more than just watching the robot. Come for the robot, stay for the humans. I felt like Alex performed better as well, worse, okay. I found mostly the show entertaining, original, great. After watching the show, I'm more excited about using AI tools for creativity. Yes! Woohoo! That's what this is all about. That's why we are here. I'm less optimistic about robots as creative storytellers. Yes! We can talk about this. Watching the show, I found myself empathizing and caring. So neutral and different. Okay, various responses. And Alex appeared mostly machine-like, artificial, and unnatural. Yeah, fair enough. So when we started doing our shows 8 years ago, we had bad reviews because we had to figure things out. And gradually the reviews got better, exponentially better. Okay, AI. But what happened in 23 is that actually the trend stopped. We started getting mixed reviews. Sometimes like this article in The Guardian by Brian Logan, who was really destroyed us after seeing a show in June. And he wrote something. Unlike music and visual art, comedy can't be easily reduced to an algorithm. Brian, I'm going to quote you. and tag The Guardian, and tag the Camden People's Theatre. Okay, we also had negative press reviews like, the robot makes the show worse. It's troubling to admit that almost all the laughs of the show came from the human, not from the human cast, but from the AI robot facing them. But at the same time, what's strange is actually the audience gave good reviews, very positive reviews. So is there some sort of bias, a sort of reaction, or some sort of defensiveness coming from people working the field? Perhaps. We still managed to get one 5-star review. That's good. Of course, the show happened in the context of a WGA strike. We all know about that. So we ended up being interviewed a lot by the press. We had like 10 interviews, BBC, Hollywood Reporter, Financial Times. So we ended up being essentially like a face of AI, and we discussed all the issues of copyright, misappropriation of artists' work, destructive impact on creative economies, the evaluation of human creative work, representational biases. I mean, at the end of the day, we are artists performing among other artists. So of course we're on the human artist side. And we want to center the humans. Lessons learned. Well, so what we're going to do next, or what we already started doing, is ditch the radio and ditch all these human in the loop because that slows down. Instead, we use glasses, AR glasses, to get lines and let the actor curate the lines. And so they read much faster and they have a choice between multiple choices. And so that reduces latency and quality of improv. So that actually goes in the direction of improving a multi-party chat. Also, individual microphones. Actually, I figured it out. I mean, it's only £1,000 to buy like 4 times wireless go-to microphones, etc., and have 8 different streams. But it does work really well. And also more comedy. Simplify the show. Thank you. Oh, and if I can plug a show, come to Edinburgh.
It's great. Now I know where I'm going at the Fringe this year in Edinburgh. So yeah, wonderful. Yeah, that's so fun. Great. Some questions.
Hi. Great presentation. I have a question regarding, because like you're an improviser and there are certain mechanics for improvising. Would it be better if we have these mechanics included in the LLM so that it is not generating all the sequences, like all the sentences like randomly, but uses these mechanisms to like narrow down and give a like couple or like, I don't know, 4 options which are like more appropriate? Like, do you think that might work?
Yeah, so like a second phase of selection. Yeah, we tried that. Actually, very funny. Corey and I, in 2018, tried to do some reinforcement learning from human feedback on improv data, but it just didn't work. And then some people at OpenAI did it. Sorry, bad joke. Anyway, but yeah, I mean, my only concern is adding extra latency. So, so if possible, just use a single LLM call, or perhaps maybe we can figure. What I didn't discuss in this, that we actually use 3 language models in parallel to be redundant mostly. So if OpenAI servers are down, we still have the Google servers. If internet is down, we have Llama 2. And so we could actually just have a system where we have some very quick answers to get us going and some slower answers, system 1, system 2, to basically, that can be curated and selected by the system. So that's a very good point.
Thanks for the very nice presentation. I was wondering, so from what you've shown, humans are still center of this creative loop, and there's a human curator and so on. Have you considered, or I don't know if this is part of your research work already, having the AI as a character of itself and just having a human proxy for it, but the AI actually delivering all of the lines and being the responsible as a character in the show without a curator, and so bringing the AI more towards actual agency in this case rather than just a creative agent?
Yes, indeed. Actually, the show starts with the robot just speaking by itself. So actually, so the AI is embodied by a robot, and now we have this very cute now. So cute, gosh, so cute. Yeah, and so I think the only reason why we were using the curation was to get the timing right. But yes, we can also just simply take the, accept some delays and just use the response. And yeah, so we are actually going to include that. Thanks.
Maybe just one quick question again. Yeah.
I'm really curious about the difference in the way that reviewers were responding and audiences are responding. And I'm wondering if the reviewers are hanging on to an old idea of what improv comedy is, and you're changing the script here, literally. And I think that the audience might have been enjoying the process. And while maybe the reviewers are still evaluating it strictly as comedy while trying to ignore the process or something like that. I just wondered if you could, I mean, I don't know if that's the answer, but I wonder if you could reflect a little bit more on that, because I think it's an interesting feature of what's going on here.
Yeah, so it's a very good point. To be honest, one of the issues I noticed with the show is that it was kind of straddling a little between science, communication, and comedy. And we were packing a lot of different things. And so sometimes the reviewers would not necessarily catch, so for instance, they didn't catch the point of improvised TED Talks. Like they said, the AI is not responding. Of course not. The AI has generated the slides. And so the improviser is justifying the slides. But one reviewer didn't actually get that. So one thing we did was in the most recent shows at Brighton Fringe a month ago, we simplified a little bit the delivery and the presentation, and also make it much more explicit that this is about having AI as a co-creation partner on equal footing. And now we started getting, again, very good reviews. And maybe also what happened is that some time flew, some time passed, and so there is a bit less anxiety and less defensiveness, and more, and reviewers might be more welcoming, let's say, of some innovations. Yes.
Brilliant. Thanks. Thanks, Peter, again. And come to Edinburgh. But bring your own tent, because you won't be able to find a place to sleep. Great. So now we move on with 3 short papers, and the first one is by Petra Jaskelainen on critical questions for sustainability research.
Thank you so much. So I will be presenting this. It's a position paper written by me and my colleague Axel Björn Hansen, also from Stockholm, from KTH. We have some problem with that. Okay, so to introduce. So to introduce this paper,
Improvised change of plan. Right. So we will try to fix the technical issues, and I would welcome Seamus to come forward. And yes, right. So he's going to talk about imagination. So let's imagine you didn't see anything and everything is going to plan. Right. Okay. So probably.
Oh, the lightning, yeah.
Yeah. No, just. Right. Okay. Great. Okay. Shall we start? Yeah. Great.
Right. I'm Seamus, and this is the Imagination tool, which is all about accessible AI image generation for children to support ideation and creative expression. So this is our team. So this was a collaboration between UAL Creative Computing Institute in London and FAM Studio, where I work. I'm doing this for Melis, who couldn't be here for visa issues, unfortunately. But yes, so UL's Creative Computing and FAM were a small kind of design innovation studio specializing in making experiences for children and families. So the goal of this project was to make AI image generation accessible for children and young people. And so this is in the context of co-design futures thinking workshops with children, which is all about translating what children are thinking to adults and decision makers. And it's to support expression for children with low kind of drawing confidence, which is like a big part of how they lose engagement in these workshops if they're not confident about it. And it has to be a fun, engaging, and safe experience. So the experience. So we're looking at the future of London in this one and exploring what that could be with children. So one of the things we found early on was traditional image generation stuff doesn't work great with how children think about ideas. They tend not to think visually and more conceptually. So putting what something looked like in a box never generated anything good. So we split the prompt into 3 questions. So what is it? What does it look like? And where can you find it? And then in the background, we combine these into a prompt with the kind of the object description and background of the image. And this also kind of helps create the idea generation side for the child. See if it works. It does, it's a video, I know. So yeah, and whoo. And so, yeah, so the flow, so we take these 3 inputs and then we go through some safety checks, and that goes through this moderation system. So that's the kind of, we have human in the loop involved in that because we want to make sure there's kind of child rights involved for all the agency and things. And then we combine that into an image prompt, and then we add additional prompt scaffolding onto it. And that kind of helps to create the consistent visual appeal, but also, yeah, makes it hard to generate harmful imagery. And because, yeah, we don't want to teach kids how to be prompt engineers necessarily in this context, because it's quite a hard thing to do. And then we put that through Stable Diffusion and generate the images. So just a few safety and usability things we found in this project. So we always begin the sessions with a discussion about AI with the children. So they kind of have a little bit of literacy, understand what it is, because normally they just say it's a robot. But kind of we can start discussing bias and things with them, which I think is really important. So we have the safety filtering to detect harmful language, but we kind of bring this in with human in the loop as well, because any kind of filtering is, you know, it's not a neutral thing to do. And we want to make sure that there's a room for children to kind of question filtering discussions and things like that. So the prompt scaffolding, which is the stuff we add on the end that as image AI people, we do automatically. But yes, that makes the generation really hard to make harmful images by using like Pixar and Disney and stuff like that. And also breaking up the prompt into short questions helps the kind of thinking process and yeah, all that kind of stuff. And then also we have Imagination Bot, which is a kind of GPT bot that we brought in to kind of help kids think about ideas. And it can also generate text based on the discussions. So for some of the kids who kind of just, the blank screen is too much, it's like a kind of way to start that discussion. And yeah, thank you. And this is, that's Mel's email. She knows everything about the technical thing, and that's mine, Seamus. I do design for kids stuff.
Great, thank you so much. So we have time for one quick question. Yes.
So my question is about the sort of safety things that you're talking about. What's the risk of unsafety even if the prompt that the student or that the kid comes up with doesn't look like it's going to happen that way? How often do you see that kind of badness?
Yeah, so lucky in the testing sessions, nothing bad happened, which was wonderful. But the kids weren't also really trying that hard because it's in a supervised school environment, so no one was going crazy. But so what we found was by using the kind of prompt scaffolding, which is, all the kind of prompt engineering qualifiers you put on the end, like it looks like Disney, Pixar, happy environment, and then using negative prompts in stability as well to kind of avoid certain things. You have to try so hard to make something that looks bad that we're kind of like confident enough to go in with a kind of, yeah, if it passes our safety checks, then it's probably going to be fine. But yeah, we can approve it on a human level as well.
Thanks a lot, Seamus. Yeah, I'm sorry, but yeah, you will have to keep it for the lunch because yeah, we have to go over to our next speaker, and Petra.
Yes, so I will continue from where I left off or where I started. So sustainability in and through digital technology has until very recently been conceptualized and approached in modernist terms, for example, focusing on quantification and optimization of the resource use. These approaches have been increasingly criticized by sustainability scholars, referring to it, for example, as shallow sustainability in environmental ethics. And sustainability in ICC and CC community is an emerging topic. So to avoid pitfalls of prior sustainability research in other venues, in this paper, we propose deep sustainability as a way to conceptualize sustainability research in CC. And this deep sustainability, rather than focusing only on the metrics, it puts the focus on relational approaches to climate crisis and fundamental transformation in values and culture. And that raises questions about what would such a perspective mean for sustainability research in ICC. In this paper, in this position paper, we are posing critical questions with the aim to spark discussion about how sustainability research ought to be approached in this community as well. So to talk a little bit more about the background, as I said, sustainability is commonly reduced to measuring, for example, carbon emissions or CO2 impact, or other very narrow and specific assessments. And this has been argued by several sustainability scholars to reduce the complexity of the problem. For example, overlooking the social and cultural dimensions of sustainability, disregarding the systemic effects like rebound effects, disregarding multi-species perspectives, and disregarding sustainability as intra and intergenerational process that spans across timescales, and also deprioritizing certain environmental ethical underpinnings of sustainability, so sort of like trivializing the questions that have to do with sustainability. So modernist approaches become a problem when they become a predominant way of doing sustainability research, and these other wider perspectives are excluded. So if we consider these critiques, we want to approach sustainability in a way that involves a relational view of the world, and it considers these difficult multidimensional environmental processes and issues in their full complexity, and doesn't obscure that complexity of the social cultural change and shift in values and culture that is required for efforts towards sustainability. So we looked into the previous proceedings of ICC and we found 4 papers that they are explicitly have to do with certain studying sustainability, but those papers take implicit stances on sustainability and how sort of that is approached theoretically. And then we have a lot of other papers that have to do with other topics, and they are often lacking a research ethics statement or reflection on how sustainability is part of that research. So what could be a way forward? What we are saying in this paper is that it would be good if we are able to take an explicit stance on sustainability as researchers, especially those who are focusing on sustainability in their papers, and engaging in a reflexive work to try to identify and discuss how sustainability is approached. So for example, difficult questions like how does new technological innovation aggravate the climate crisis, and CC technology very specifically. Like when we design and introduce new technologies here, what will be the impact on these different dimensions that I talked about? What is the potential afterlife of the technologies? What kind of wider effects or rebound effects could emerge when they're introduced into the society? And why has sustainability research entered ICC venue so late? And how can we keep that as a part of the research agenda in coming years? And then this one, what epistemological commitments are taken in CC research when it comes to sustainability? So that relates to what I was talking about earlier. So how do we basically approach sustainability in terms of like theory that draws from sustainability research, and what implications does that have for that research? And lastly, what stakeholders, human, non-humans, both artificial and natural, get to matter in CC research when we work with the technologies and study them. So in this short paper, we present a review basically of literature from prior sustainability research to advocate for a careful approach in how questions of sustainability should be approached. And then we conceptualize deep sustainability as an approach that is relational and takes into consideration various critiques. We basically want to raise this question for further discussion. How should we approach sustainability research in this community in the future? And we have argued that there is a need to adopt a broader approach to sustainability research and prioritize critical questions. And we raise a set of questions that can serve as a pointers to examine the epistemology, histories, current practices in CC research, and their implications when it comes to sustainability. Yes, that's it. Thank you.
Thank you very much, Petra. Any questions? I cannot really see you. Right, so maybe, yeah, okay, Teresa.
Thank you so much for the presentation. I guess you pose a lot of questions, and that's really good for us to think about. I just don't know how to start. I guess, did you have any suggestions about how we can start thinking about sustainability and in our work?
Yeah, so basically, when we were writing this paper, we were reflecting a lot on should we do something concrete or not. We thought position paper is better because if we want to criticize the approach of like starting to build something to fix things, it's better that we actually raise these questions in another format. So I think discussing, bringing these questions into like community discussions in our everyday work when we are developing the technologies and going back and looking at the projects, basically like how is sustainability part of this? And there's a lot that we can do as a community. We can include statements in the papers. We can bring these discussions into the community meetings. But also in this paper, we thought like it might be hard to understand where to start, like as you asked. So we provided some examples of alternative ways of designing technology, like slow design, for example, designs that are going against cornucopian approaches in HCI. And I think actually in this session, the first project with the nature, that was a good example using a lot of those approaches. Yeah, your paper. Yeah.
Thank you, Gentra. Really nice. Good. We come now to our last paper by Ika on human creativity and uncontrollable generative AI.
Thank you. So my name is Ikka Hauhio. I'm from the University of Helsinki, and my paper is on uncontrollability and how that might enhance creativity. So basically, this is the application of the creative systems framework by Geraint to generative AI, especially used iteratively. Like here, we have a concept in our mind, like this painting of a cat, and we want to generate it with a generative AI program. So we start inputting prompts, and we start getting results, and this iterative process essentially explores the space, the artifact space of the generative AI program, thus similar to the Boden's exploratory creativity idea. Although here we have two spaces, actually the prompt space and the artifact space, and the user can only directly explore the prompt space, and the artifact space is then through this mapping of the generative AI program to the artifact space. And while the user moves here, they might get new, better data, like in the concept was painting of a cat, and the stars signify that it's also better as it's a more high quality artifact. And my thesis is that if this interaction is uncontrollable somehow, so for example, if the user tries to get something out of it and the system goes to another direction, and here this direction is not in the latent space, it's more like in the space of the user. Like we can see that, for example, here we tried to get this street cat painting, but instead we got the street cat painting, but that actually has, the cat has like paint on the cat. So the system misunderstood what painting here meant and added paint to the picture, which was not what was meant by the user, but the user liked it. And this kind of thing might transform the user's idea of what they want, and thus introduce this kind of transformative aspect to it. And here, of course, we are not transforming the generative AI or anything like that. We are transforming the ideas of the user. So the user's concept of what they want changes during this process. In my paper, I propose several metrics that could be used to quantify this thing. So for example, we could measure how many artifacts actually are in the concept set that the user initially provided, and how many of them are valuable, and how many of them are both. So in that previous example case, we get that only 2 were in concept set, 2 were valuable, and 1 was valuable and in the concept set. But that doesn't necessarily mean that this is a bad thing. It's uncontrollable in the sense that we didn't get as many like valuable and goal fulfilling results as we could have, but we got something else. And that might be a good thing for creativity of the user, because they get new ideas through these systems. Here are some ideas how I could continue this research after this paper, because this was only a short paper. I didn't have time to think of all the implications of this, but here are some ideas I give in my paper. So first of all, both the user and the system could have models of each other. And of course, the user has a model of the system, but some systems also have a model of the user. For example, I have some examples of recommender system literature I could use here, where the modeling of the user is very important. So as the user uses the system, the model changes, and the system and the user become more and more adaptive, such in the co-creativity papers discussed previously today. And this also means that the controllability of the system changes. And we can measure that controllability, for example, with these experiments I proposed in the last slide. And today I would like to, in future, I would like to focus more on these changes that happen in controllability and changes that happen in these models, and also how can we use this to our advantage to make better tools for artists. Thank you.
Thank you very much, Ika. Right. Any final questions for this session? Yeah. Wish.
Yeah, this is really interesting, this idea of using the generative models almost like I think it's almost like a game in a way. So I just my comment is more, are you familiar with Jess Hammer's work? It's about using games to transform the ideas. Okay, so it's basically to comment that there's actually some work on using games to change the player's mind. So maybe it would be nice to make some parallel between this and games. Or if you want to comment, do you think this can be compared to a game in some way?
Yes, thank you. I do think it can be compared to a game, and in fact these trees maybe here that I have here look very much like game trees in game AI. And I have some ideas of how to relate this game tree idea. I'm not sure if that was what you meant, but that is one thing I'm intending to also study. Thank you.
Thanks. Thank you very much. So thanks, Ika again. And thank you to all of our speakers in this session. So I think Maria has some words for us.
Yes, always. It's good that we end a few minutes earlier because the lunch will be intense. Let's call it that. No, we have an hour lunch, but during that time, it would be great if we all could take a photo as well. So at some point, our photographer will come and gather us all to take a group photo. If you're in the middle of lunch, please join us anyway. And remember where you put your food so you can come back to it. So keep an eye out for us coming to usher you out. As for what happens in the afternoon, we have some seats available still for the candy. Some people canceled. So if you feel like, well, this is the one opportunity to go make candy in Gränna, you have a chance to do that. Same goes for beer tasting. We have a few available seats there as well. So learning about beer brewery in the middle of a beautiful little region in Sweden, try a few different beers, eat some sweets or whatever they're offering, I'm not sure. Talk to me and we will sign you up for that as well. If you want to leave your bags during any time, now is the chance. And of course, that means that you have to run really quickly to your hotel. But I would recommend instead to actually take it with you because you can leave it in the bus. So unless it's super heavy, I recommend to allow yourself the relaxing moment of having lunch, take your bag with you, leave it on the bus for the hike and stuff like that. Sounds good? Okay, in that case. Oh, question? Yeah.
When we had the option to select that,
yeah,
the word was walk.
Yeah.
Should we have special shoes or?
I just said there's still available seats for candy and and beer. No, so okay, let me put it like this. The hike is essentially walking up the hill and then walking down the hill. And the hill is a small mountain. If you think that's a hike, I don't know. You can walk, it's paths, so you can walk with a decent shoe. If you wear heels, bad idea. But you know, anything else will not be a major problem. We're not going to go through some mud or something like that. It will be a little bit stony and stuff like that. But if you got decent shoes on with a flat sole, you should be fine. Right? Yeah. Yep.
Hello, I'm Dan Brown. I think a lot of you know me. We have an online paper reading group that we've been running for about 8 or 10 months, and some of you are part of that. And we don't have a session this month because there's a conference, I hear. So if you would like to join us to talk about this group or consider being part of us, please look for us at lunch today. Thank you.
Oh, and one more thing. In order to make the schedule work and to be respectful to each other, please come and talk to the people working at tech support before the session starts tomorrow so that everything can run smoothly somehow. Cool. All right. Then thank you and enjoy your lunch.